The polar regions, vast and unyielding, conceal secrets that challenge both science and imagination. Beneath layers of ice, within frozen lakes, and across windswept expanses of snow, anomalies emerge that seem to defy nature itself. Preserved corpses from doomed expeditions, inexplicable subglacial structures, and signals that hint at life or technology long hidden from human eyes. These are discoveries that shouldn't exist, yet endure in silence, waiting to be understood. Through remote Arctic and Antarctic landscapes, you will trace the paths of vanished explorers, scrutinize the evidence of strange geological and biological phenomena, and confront mysteries that leave even the most seasoned scientists unsettled. As we navigate icebound valleys, subterranean lakes, and the remnants of lost civilizations, each revelation builds a tapestry of cold wonder, where the line between history and the impossible blurs and the frozen world guards its enigmas with unyielding quiet. The Lake Vostok organism signals. Beneath the interior of East Antarctica, where temperatures remain far below freezing and the ice sheet reaches nearly 4 kilometers in thickness, lies a feature that was never meant to be accessible to life, let alone studied. The surface above Lake Vostok appears static and inert, a place defined by pressure, darkness and silence. Yet for decades it has been the focus of growing unease among glaciologists and microbiologists. The lake itself, sealed beneath ice for at least several 100,000 years and possibly far longer, represents one of the most extreme environments on Earth. What unsettled researchers was not merely the lake's existence, but the mounting evidence that something within it appeared active, responsive, and persistently alive. Lake Vostok was first inferred in the 1970s through airborne radar surveys conducted by Soviet scientists, who noticed a vast, unusually smooth region beneath the ice near Russia's Vostok station. Subsequent radar and seismic measurements confirmed the presence of a subglacial lake roughly the size of Lake Ontario, stretching over 250 kilometers in length and reaching depths exceeding 500 meters in places. Pressure from the overlying ice keeps the water liquid despite ambient temperatures that would otherwise freeze it solid. For years, Lake Vostok was treated as a geological curiosity, but its complete isolation from sunlight, atmosphere, and surface ecosystems soon made it a biological question that science was not prepared to answer. As interest grew, scientists realized that Lake Vostok was not alone, but part of a vast network of more than 400 subglacial lakes hidden beneath Antarctica. Vostok stood apart due to its size, depth, and longevity, with models suggesting it may have been sealed off for up to 15 million years. This extreme isolation implied that any life within would have evolved without contact with the modern biosphere, surviving on chemical energy alone. The idea challenged long-standing assumptions about the limits of life, yet remained theoretical until indirect signs began to emerge from the ice itself. These signs did not arrive as visible organisms, but as chemical and biological traces embedded within frozen layers. The key evidence came from accretion ice, a type of ice formed when lake water freezes onto the underside of the overlying ice sheet. As the ice sheet slowly flows across Lake Vostok, water from the lake refreezes, trapping particles, dissolved gases, and potential biological material within its crystalline structure. Ice cores extracted near Vostok Station revealed unusual concentrations of salts, organic carbon, and trace elements inconsistent with surface contamination. More unsettling were reports of microbial DNA fragments detected in these layers, suggesting that biological material existed in the lake water below, despite the immense pressure, darkness, and lack of oxygen. In 2012, after decades of planning and international debate over contamination risks, a Russian research team successfully penetrated the ice and reached Lake Vostok's surface water. Rather than directly sampling liquid water, the drilling process allowed lake water to rise into the borehole and freeze, preserving it as ice for later analysis. The results, published in peer-reviewed studies, indicated the presence of microbial signatures, including sequences associated with bacteria known to survive in extreme environments. While the findings were cautiously framed, they confirmed that biological signals were present where none were expected, intensifying questions about how such organisms could persist. What made these signals particularly disturbing was not merely their presence, but their apparent diversity. Analyses suggested the existence of organisms adapted to high pressure, low temperature, and chemically unique conditions, including possible chemoautotrophs capable of deriving energy from minerals rather than sunlight. Lake Vostok's water is believed to be supersaturated with oxygen due to ice melt under pressure, creating an environment chemically hostile to most known life forms. Yet the biological traces implied metabolic activity adapted to these extremes, raising the possibility that life had not only survived, but stabilised within a sealed system untouched by surface evolution. Complicating the picture further were radar observations indicating subtle variations within the lake itself, including regions of differing reflectivity that hinted at water circulation, sediment interaction, and possible thermal gradients. These internal dynamics suggested that Lake Vostok was not a stagnant pool, but a slowly evolving environment shaped by geothermal heat from below and ice movement above. If true, this would provide the conditions necessary for long-term biological processes, despite the absence of external inputs. The implication that an entire ecosystem could function in complete isolation unsettled researchers who had long relied on surface-based models of habitability. The broader implications extended far beyond Antarctica. Lake Vostok quickly became a terrestrial analogue for extraterrestrial environments, particularly the subsurface oceans believed to exist on Jupiter's moon Europa and Saturn's moon Enceladus. If life could persist beneath Antarctic ice for millions of years, it strengthened the argument that similar ecosystems might exist elsewhere in the solar system. Yet this comparison also heightened concern because Lake Vostok demonstrated that such life might be fundamentally alien in its chemistry and behaviour. The signals detected were familiar enough to recognise, but strange enough to resist easy classification. Despite careful protocols, skepticism surrounded every discovery, with critics questioning whether detected DNA could be the result of contamination introduced during drilling or sample handling. These concerns were not dismissed lightly, and follow-up studies attempted to account for every known contaminant source. While some sequences were indeed linked to surface organisms, others remained unexplained, matching neither laboratory controls nor known contaminants. This unresolved residue of biological data continued to fuel debate, not because it proved the existence of life, but because it refused to disappear under scrutiny. As research continued, Lake Vostok remained inaccessible to direct exploration, protected by international agreements designed to preserve its pristine condition. New drilling technologies were proposed, then delayed, as scientists weighed the risks of irreversible contamination against the need for answers. In the meantime, satellite measurements, ice flow models, and chemical analyses of accretion ice continued to refine the picture of a hidden world beneath the ice. Each new dataset added detail, but also reinforced the sense that Lake Vostok was not behaving as an inert body of water should. What makes the organism, signals of Lake Vostok, truly unsettling is not that they suggest life exists in an extreme place, but that they imply continuity, resilience, and adaptation in an environment that should have erased all biological activity long ago. The lake's isolation means that whatever exists there has persisted without genetic exchange, sunlight, or seasonal change, evolving under constraints so severe they challenge the definition of survivability. The signals are faint, fragmented, and incomplete, yet they are persistent enough to resist dismissal, lingering in the data like a quiet refusal to conform. Below Antarctica's ice, something continues to leave traces in the frozen record, waiting in the dark where no living system was ever supposed to endure. The Nazi structures of Queen Maud Land. Antarctica was never meant to contain the physical traces of deliberate human construction tied to a modern industrial state operating beyond any reasonable logistical reach. For most of the 20th century, the southern continent was understood as a place hostile to permanence, where even temporary survival demanded extraordinary effort and where human activity left little behind once expeditions withdrew. This assumption made Antarctica feel historically empty, a stage entered briefly and abandoned without residue. Yet within Queen Maud Land, a vast sector of East Antarctica claimed by Nazi Germany before the Second World War, accounts began to surface that challenged this expectation, hinting that something structured, planned, and intentional may have been left behind where no such imprint should exist. Official records describe Germany's Antarctic expedition of 1938-1939 as brief, methodical, and limited in scope, Yet those documents leave critical questions unanswered. The expedition, carried out by the vessel Schwabenland, focused on aerial surveying and territorial reconnaissance, using seaplanes to photograph large swathes of Queen Maud Land from above. These flights resulted in thousands of images and the symbolic act of dropping markers to assert a claim later named Neuschwabenland. Nowhere in surviving documentation is there an explicit reference to construction or long-term occupation, and the mission's duration appears insufficient for anything beyond surface-level exploration. It is precisely this neatness that later observers found unsettling. Long after the expedition faded from public attention, scattered reports began to reference unnatural features near isolated rock outcrops that defied simple classification. Some described tunnel-like openings partially obscured by ice, while others pointed to geometric cavities that did not resemble typical glacial formations. These accounts were rare, inconsistent, and often second-hand, yet they shared a common theme of deliberate modification rather than natural erosion. Queen Maud Land's nunataks, rocky peaks protruding through the ice, became focal points for these claims because they represented the only locations where construction could plausibly interact with exposed terrain. The difficulty lay in separating misinterpretation from anomaly, especially in an environment known to distort perception. Constructing anything durable in this region would have required sustained access to fuel, materials and shelter that the known expedition timeline does not easily explain. Even modern Antarctic bases depend on continuous resupply and advanced insulation to remain operational. In the late 1930s, such infrastructure would have been exceptionally difficult to establish unnoticed, particularly given the limited technology of the time. Any underground or semi-submerged structure would have demanded excavation, reinforcement, and heating in conditions where machinery performed poorly and human endurance was severely tested. The absence of clear logistical evidence stands in sharp contrast to the complexity implied by the reported features, creating a mismatch that has never been resolved. The collapse of Nazi Germany severed paper trails as thoroughly as it destroyed cities, leaving polar activities documented unevenly and, in some cases, not at all. Archives were lost, destroyed, or deliberately purged, while surviving records were often fragmented or selectively preserved. This archival damage created an informational vacuum into which speculation easily flowed. While historians have reconstructed much of Germany's polar ambition from remaining sources, the absence of comprehensive documentation regarding Queen Maud Land has left room for unanswered questions. The uncertainty is not rooted in dramatic claims, but in the simple fact that the historical record ends abruptly where explanation would be most needed. When geopolitical interest in Antarctica quietly resurfaced during the mid-20th century, attention returned to areas previously dismissed as strategically insignificant. During the Cold War, the continent became a focus of scientific, military and intelligence-related concern, prompting renewed mapping efforts and aerial surveys. While these missions were primarily scientific, they also re-examined regions first charted decades earlier. Queen Maud Land's earlier association with Nazi Germany gave it an additional layer of sensitivity, even as no official statements acknowledged anything unusual. The lack of public findings did not dispel curiosity, instead reinforcing the perception that certain questions remained deliberately unexplored. Speculation persists not because of dramatic claims, but because no single practical explanation fully resolves the contradictions left behind. Natural ice caves, wind erosion, and glacial movement can create formations that appear artificial, yet some reported features seem to exhibit symmetry or internal consistency inconsistent with random processes. Conversely, the idea of concealed construction strains credibility when weighed against logistical realities. Each explanation accounts for part of the picture while leaving another part unresolved, producing a tension that resists closure. This balance between plausibility and improbability has kept the subject alive despite a lack of definitive proof. Ice accumulation in Queen Maud Land does not preserve intention so much as obscure it, compressing brief human actions into near invisibility. Snowfall, wind-driven drift, and glacial flow can bury structures within years, altering surface features until they no longer resemble their original form. Even confirmed Antarctic installations have been lost beneath ice when abandoned, leaving little trace of their presence. If any structures existed in Queen Maud Land during the late 1930s, decades of accumulation could have rendered them unrecognisable, merging human geometry with natural contours. This environmental erasure complicates any attempt to verify or disprove past construction. Measured against the design and documentation of later Antarctic research stations, the reported anomalies appear curiously out of alignment. Established bases from the post-war era follow clear architectural logic with visible access points, standardized layouts, and extensive records detailing their construction. By contrast, the alleged features in Queen Maud Land lack corroborating documentation and do not conform neatly to known engineering practices of the time. They appear neither fully temporary nor clearly permanent, existing in a conceptual grey area that makes classification difficult. This inconsistency reinforces uncertainty rather than dispelling it. Attempts to close the matter through dismissal have repeatedly failed, largely because the available evidence refuses to settle into certainty. Each effort to categorize the reports as myth, misinterpretation, or exaggeration encounters unresolved details that do not align cleanly with those conclusions. At the same time, no verified discovery has emerged to confirm the existence of hidden structures conclusively. The result is an unresolved historical anomaly sustained not by sensationalism, but by contradiction. The mystery persists because it occupies a narrow space where explanation and doubt remain equally incomplete. What remains today is a landscape that offers neither confirmation nor refutation, only the quiet persistence of unresolved possibility. Queen Maud Land continues to exist largely untouched, its interior rarely visited and its past only partially understood. Satellite imagery and modern surveys have improved coverage, yet they have not erased uncertainty surrounding earlier reports. The ice has smoothed over decades of speculation without answering the questions that first gave rise to it. In this silence, the boundary between history and absence remains indistinct. If anything was ever constructed there with purpose rather than presence in mind, the ice has ensured that only the question survived intact. The blood falls phenomenon. No one expects colour to break the Antarctic ice, yet at the edge of Taylor Glacier, a deep red stain appears where only white should exist. Its sudden presence against the stark, frozen landscape is both mesmerising and alarming, drawing attention from early explorers and modern researchers alike. The hue is not superficial, it seeps slowly from fractures in the ice, staining surfaces far below. For a continent defined by monochrome extremity, the sight of vivid red liquid challenges perception and expectation. It appears almost impossible, yet it persists, refusing to be ignored by anyone who approaches the glacier's terminus. When explorers first recorded this phenomenon in the early 20th century, its appearance invited immediate confusion rather than explanation. Early notes describe flowing streaks that contrasted violently with the surrounding ice, likened to bleeding wounds in an otherwise immaculate expanse. Observers could find no precedent for such a sight and lack the tools or context to analyse it properly. The feature was catalogued, photographed, and largely left to mystery, as attempts to approach it physically were hindered by frigid conditions and the danger of unstable ice. Even then, those who saw it recognised an incongruity that would not be explained for decades. Unlike a steady flow, the red discharge emerges slowly and irregularly, creeping down the ice face as if responding to unseen pressure. The liquid does not pour continuously, it dribbles and pools in subtle, uneven currents, leaving irregular stains that accumulate over time. Seasonal variations in temperature and ice movement influence its appearance, yet no pattern fully predicts its intensity or timing. The visual effect is eerie, at once organic and inorganic, suggesting a force or process hidden beneath layers of ice and snow. This movement imbues the glacier with a sense of life where none should exist, making observers instinctively aware of a system operating beyond normal expectation. Modern analysis revealed that the liquid carries extremely high concentrations of dissolved iron, salt, and other minerals drawn from deep beneath the glacier. Its chemical composition is unlike that of typical surface runoff, demonstrating a composition shaped by centuries of isolation. The iron oxidizes quickly upon exposure to the atmosphere, producing the deep crimson that stains the ice. Other minerals suggest interactions with rocks trapped beneath the glacier for millennia. Scientific studies confirm that this is not contamination or a recent phenomenon. The red flow is the visible product of a natural chemical process occurring far beneath the frozen surface. The source of this fluid is not surface meltwater, but a trapped brine reservoir sealed below the ice for thousands of years. Pressurized and isolated, the brine exists in darkness, cut off from sunlight and atmospheric oxygen. Its existence implies long-term chemical stability under conditions that would normally prevent liquid water from persisting. Geophysical surveys show the brine is held in pockets and fractures beneath the glacier, slowly moving upward along structural weaknesses. The process is invisible until the brine reaches the terminus and contacts the air, yet its effect is immediate and visually jarring, spilling its scarlet signature across the glacier's icy face. Within that oxygen-starved environment, specialized microorganisms persist by using chemical reactions instead of sunlight to survive. These extremophiles metabolize iron and other dissolved minerals, producing byproducts that subtly influence the chemical balance of the brine. Genetic studies reveal that these microbes are unique to the subglacial ecosystem, adapted to survive under pressures, salinity, and darkness that would annihilate most surface organisms. Their activity explains the persistence of the brine's red color once it emerges, linking biological processes to a phenomenon that otherwise appears purely geological. The presence of life in such a hidden extreme environment adds layers of wonder and unease to what might otherwise be a simple chemical reaction. Once exposed to air, the iron-rich liquid oxidizes rapidly, turning darker as it spreads and permanently staining the surrounding ice. This oxidation process is predictable chemically, yet unpredictable visually. Some surfaces turn rusty brown, others deep crimson, while textures of flowing ice alter the apparent color further. Over time, these stains accumulate into irregular streaks, creating permanent reminders of the brine's path. Observers note that even brief exposures leave lasting marks, a silent record of subglacial activity. It is both natural and unnatural, familiar in chemical principle yet disturbing in its visual defiance of the Antarctic's otherwise pristine whiteness. This behavior contradicts nearly every expectation of how Antarctic glaciers are supposed to look and move. Glaciers are typically defined by monochrome expanses of white and blue, shifting slowly with imperceptible changes. The intrusion of a vivid bleeding red undermines assumptions about what these frozen rivers can contain. Unlike other seasonal melt or surface staining, Bloodfalls remains confined yet persistent, an anomaly against the predictable background of ice and snow. Its flow is not dramatic in volume, yet the contrast is extreme enough to demand attention, causing every observer to pause, question and wonder at the hidden processes beneath the surface. Even after decades of careful observation, Bloodfalls retains a disquieting effect on those who witness its steady, unnatural flow. Familiarity does little to mitigate the emotional response. Scientists, photographers and expedition teams report a lingering sense of wrongness when confronted by the crimson rivulets. The combination of movement, colour and isolation creates a sensory experience that is at once scientifically explicable and viscerally unsettling. While knowledge reduces mystery, it cannot fully normalise the sight, leaving a subtle tension between understanding and instinct, as though the ice itself has bled where it ought not to have. Scientists often point to this site as a natural analogue for icy worlds beyond Earth, where similar chemical processes might occur unseen. Europa, Enceladus, and other moons with subsurface oceans are theorized to host briny pockets where life could survive in darkness and pressure comparable to that of Taylor Glacier. Bloodfalls demonstrates that extreme life can persist and even leave visible traces in a seemingly inhospitable environment. Yet the analogy reinforces unease rather than diminishes it. If a place on Earth can appear so alien in plain sight, the possibilities beyond our planet seem equally disquieting and strangely familiar at the same time. At present, the sight of red cutting through frozen blue continues to resist emotional normalization. The juxtaposition is immediate, unavoidable, and permanent in its impact on perception. Visitors describe the sensation of witnessing something both alive and chemical, tangible yet alien, as if the glacier itself has produced a form that should not exist in a place so cold, bright and empty. Scientific inquiry can explain its composition, origins, and even microbial contributions, yet explanation never fully removes the sense of unease that accompanies the visual experience. Bloodfalls remains a reminder that understanding and disturbance can coexist in the most unlikely of places. Understanding why the ice bleeds has never fully answered the quieter question of why it still feels like it shouldn't. The Greenland ice core atmospheric anomaly. The atmosphere of centuries past revealed itself in ways scientists could not have predicted, captured within tiny bubbles that seemed to defy established understanding. These pockets of air, trapped as snow compacted into ice over millennia, contain detailed chemical signatures of Earth's climate long before modern records existed. For researchers, the challenge is not merely extracting these bubbles, but interpreting them in a context that makes sense against the known history of atmospheric behaviour. Yet some readings consistently refuse to conform, hinting at events or processes that remain unexplained and challenging assumptions about the stability and predictability of the planet's past. Drilling campaigns such as GISP-2 and GRIP have revealed centuries of trapped air, each bubble a tiny time capsule preserving the chemical whispers of ages long past. The precision required to extract these cores without contamination is extraordinary, with specialised drills capturing continuous samples from hundreds of metres below the surface. Each layer corresponds to a year, season, or even a fraction of a season, offering a frozen archive of gases, particles, and isotopes. For decades, scientists have relied on this meticulous layering to reconstruct Earth's climate history. But some anomalies appear repeatedly, raising questions that no standard model can yet resolve. Amid the regular rhythm of seasonal deposition, researchers discovered unexpected spikes in isotopes and gases that contradicted the climatic patterns known for those eras. In some layers, sudden increases in carbon dioxide or methane occurred, where a stable plateau would be expected, while other isotopes suggest atmospheric changes that do not correlate with volcanic eruptions, solar cycles, or known natural phenomena. These irregularities are subtle yet undeniable, showing up consistently in multiple cores, and they leave scientists grappling with the idea that the historical climate may have been subject to forces still invisible to modern instrumentation. These anomalies challenge models built on volcanic activity, solar cycles, and greenhouse gas fluctuations, creating a temporal puzzle that has perplexed climatologists. Established climate reconstructions derived from centuries of data predict smooth progressions or predictable perturbations, yet the ice cores suggest otherwise. Some events appear to have occurred abruptly, leaving chemical footprints inconsistent with gradual environmental change. The result is a series of questions that no model can currently answer with certainty, forcing scientists to reconsider how confidently they can map the planet's atmospheric history over the past tens of thousands of years. The irregular signals appear consistently in multiple ice cores, extracted hundreds of kilometers apart, suggesting the phenomenon is neither localized nor accidental. Whether measured in central Greenland or toward the periphery, these same unusual spikes recur, indicating a process affecting the wider atmosphere rather than an isolated pocket of contamination. This repetition rules out technical error and implies that the anomaly represents a genuine environmental event or series of events preserved in ice. Yet despite its repeated presence, the cause remains elusive, resisting all conventional explanations and leaving the chronological record incomplete in a way that is both scientifically fascinating and unsettling. Advanced techniques, including mass spectrometry and isotope ratio analysis, have confirmed the authenticity of these readings, leaving contamination as an unlikely explanation. Scientists have painstakingly accounted for drilling artifacts, laboratory error, and handling procedures, yet the anomalies persist. Every layer, every bubble, and every trace gas has been subjected to rigorous verification, reinforcing the idea that what they see is real. The more the data are scrutinized, the more the anomaly resists reconciliation with expected patterns, suggesting either an unknown atmospheric process or an extraordinary environmental event preserved in ice for centuries. The implications extend far beyond Greenland, raising questions about the stability of Earth's atmosphere and the processes that govern chemical distribution across millennia. If these anomalies represent events that current models cannot predict, then understanding past climate shifts may require reconsidering fundamental assumptions. They could imply rapid fluctuations in greenhouse gases, previously undocumented interactions between atmospheric layers, or forces yet unrecognized in climate science. Each discovery both illuminates and complicates the picture, leaving scientists aware that the Earth's historical record, while vast, may hold surprises that challenge the foundations of environmental understanding. Researchers have explored correlations with known global events, major eruptions, solar minima, or cosmic radiation, but no single factor fully accounts for the anomaly. Volcanic ash layers, tree ring data, and icebound isotopes provide partial overlap, yet none explain the specific timing, intensity, or chemical composition observed in these ice cores. Even cross-referencing data from Antarctica and other polar sites leaves gaps, highlighting the possibility that these anomalies represent phenomena outside the range of documented natural events. The puzzle is both technical and conceptual, forcing climatologists to confront the limits of their interpretive frameworks. Layer by layer, the ice preserves a record that refuses to align neatly with expectations, a chronological stubbornness that keeps scientists returning to the same puzzles. Each year's accumulation, each millimetre of compressed snow, seems to insist on telling a story different from what models predict. The anomaly is embedded within this continuity, quietly contradicting assumptions without ever becoming dramatic. For those who study these records, the effect is cumulative, a growing sense that Earth's atmospheric history may include events or processes that remain invisible in all other proxies, leaving an open-ended question about what truly happened. Scientific debate continues, with papers proposing competing explanations, yet none fully reconciles the data with established understanding, leaving the anomaly unresolved. Some researchers suggest unknown chemical cycles, others hypothesize brief and extreme atmospheric events, while yet another camp points to solar or extraterrestrial influences. Peer-reviewed discourse illustrates both the rigour and the frustration of the scientific community. The data are solid, reproducible, and verified, but their interpretation eludes consensus. This ongoing uncertainty is rare in such a tightly studied field, making Greenland's ice a rare repository of unresolved temporal mystery. Viewed conceptually, Greenland's ice functions as a chronological archive, silently recording atmospheric history while concealing questions humanity cannot yet answer. Each layer is a witness, offering insight while withholding full comprehension. The deeper the core, the older the air, and the more the anomalies seem to whisper of processes and events that current science cannot fully explain. Time itself is embedded in the ice, yet even the passage of millennia cannot clarify why these readings contradict expectation, leaving a subtle but persistent sense of unease for those who study them. The ice holds its secrets silently, challenging the certainty of every assumption humanity has made about the past. The Devil's Hole Antarctic Signal. A peculiar vibration was first detected deep beneath the Antarctic ice, registering on instruments in a pattern that scientists could not immediately explain. The readings, subtle yet persistent, emerged during a routine survey of subglacial structures, capturing attention because they did not match known icequake patterns or natural glacial movements. Initial skepticism gave way to curiosity as the signals persisted, showing a regularity that suggested an origin beyond random geological noise. Researchers were puzzled by how a continent known for its frozen stillness could produce such persistent, measurable phenomena, challenging the understanding of Antarctica as a static, inert environment. Seismic sensors, hydrophones, and electromagnetic detectors captured the signal in painstaking detail, each reading meticulously logged and cross-checked for errors. Multiple arrays spaced over kilometers of ice and embedded at varying depths recorded the same oscillations, confirming that the phenomenon was not localized to a single sensor. Data were transmitted in real time to monitoring stations, where scientists began comparing frequency, amplitude, and temporal variation. The combination of instruments ensured that no single measurement error could account for the anomaly, adding credibility and deepening the mystery surrounding this unexplained Antarctic signal. The oscillations repeated at irregular intervals, sometimes sharp and sudden, sometimes low and sustained, defying known geological or glacial processes. Analysts noted patterns in the waveform that were consistent enough to suggest structure, yet inconsistent enough to resist classification. The signal's behaviour did not correspond with typical tectonic tremors or shifts in ice mass, and its range spanned distances that made localised causes unlikely. This irregularity became a source of fascination, as the signal hinted at an underlying process that had never been observed before, prompting scientists to consider explanations beyond conventional glaciology. Initial hypotheses proposed subglacial movement, pressure shifts, or ice quakes, but none could fully account for the signal's timing, structure, and intensity. Researchers examined ice flow models, calculating stress and strain across kilometers of frozen terrain, yet the predicted vibrations never matched the recorded frequencies. Pressure release events, such as the sudden collapse of ice bridges or minor crevasse shifts, were too brief or weak to explain the observed persistence. Even complex models of glacial resonance failed to replicate the amplitude or pattern, leaving scientists with a phenomenon that resisted all conventional interpretation despite exhaustive testing. Independent research teams confirmed the same patterns using different instruments, eliminating the possibility of technical malfunction or procedural error. Collaboration across multiple research stations strengthened the anomaly's credibility, with each team reporting identical oscillations under different environmental and operational conditions. The convergence of findings across independent datasets suggested a real and reproducible event, forcing the scientific community to acknowledge the phenomenon as genuine. Despite repeated attempts to simulate or explain it, the signal maintained its enigmatic character, a constant reminder that even in the most meticulously studied environments, nature can produce the wholly unexpected. Closer analysis revealed subtle anomalies, brief modulations in frequency, slight seasonal variation, and pulses that appeared almost deliberate in nature. These minor inconsistencies, initially dismissed as noise, became the focus of detailed statistical analysis, revealing a recurring complexity that hinted at an unknown controlling mechanism. Patterns emerged, suggesting that the signal might respond to seasonal temperature gradients or subtle shifts in ice density, though the mechanisms remained theoretical. The presence of modulation, unexpected timing, and amplitude variation deepened the sense of mystery, challenging scientists to consider possibilities that had never before been proposed in subglacial research. The phenomenon raised questions about hidden subglacial processes, suggesting that Antarctica might harbour dynamics the scientific community has yet to document. Researchers began speculating about unknown cavities, pressurised water channels, or previously unrecorded geological formations beneath the ice sheet. The anomaly hinted at energy sources or mechanical processes operating under conditions that were both extreme and inaccessible. This discovery implied that the frozen continent, often regarded as uniform and inert, could conceal intricate physical dynamics capable of producing signals detectable across kilometers of ice, opening a new frontier for glaciological and geophysical investigation. Researchers have explored correlations with known global events, major eruptions, solar minima, or cosmic radiation, but no single factor fully accounts for the anomaly. Volcanic activity, which can create tremors and release gases, showed no consistent temporal alignment with the signal. Solar phenomena and geomagnetic fluctuations were considered, yet they failed to replicate the characteristic pattern or repetition observed in the ice. Even regional glacial shifts and oceanic tidal effects could not explain the precise behaviour of the oscillations. Each potential explanation provided only a partial overlap, leaving the signal's origin unresolved and reinforcing the sense that something entirely unrecognised was at play. Over months and years, the signal persisted with startling consistency, reinforcing the sense that it was not random noise but a genuine anomaly. Continuous monitoring revealed that, despite seasonal temperature changes and ice movement, the oscillations remained detectable, as if insulated from external influence. Scientists noted that while minor amplitude variations occurred, the overall pattern was remarkably stable, defying expectations for subglacial phenomena. The persistence across timescales heightened both intrigue and frustration, as repeated observation confirmed the signal's reality, while simultaneously deepening the enigma surrounding its source and purpose. Speculative considerations emerged cautiously in peer-reviewed papers, including suggestions of unknown caverns, undiscovered geological formations, or phenomena entirely outside current understanding. While most hypotheses remain unproven, they reflect the growing acknowledgement that the anomaly represents a frontier of Antarctic science. The signal has prompted interdisciplinary discussion, drawing geophysicists, glaciologists, and even engineers into collaborative inquiry. Each theory adds texture to the puzzle, but none fully reconciles the data with known physics, leaving a lingering sense that the continent itself may harbour processes beyond contemporary human comprehension. Antarctica continues to challenge the limits of human detection, revealing that beneath its silent expanses, nature may communicate in ways we are only beginning to perceive. The Devil's Hole signal demonstrates that even in one of the most isolated, studied and extreme regions on Earth, persistent and inexplicable phenomena can exist. Researchers are forced to reconcile confidence in their instruments with the reality of something unaccounted for, acknowledging that discovery is not always accompanied by understanding. The signal endures as both a scientific puzzle and a testament to the continent's hidden complexity, offering no easy answers and only more questions. The sound continues beneath the ice, as though the continent itself whispers secrets no one can fully interpret. The Siberian permafrost megafauna revival. Excavators in Siberia unearthed the remains of a mammoth so remarkably preserved that even soft tissue and hair survived the millennia, sparking immediate scientific fascination. The permafrost had acted as a natural freezer, halting decomposition in a way that preserved structures once thought impossible to endure tens of thousands of years. For researchers, the discovery was more than a paleontological curiosity. It suggested that frozen environments could serve as time capsules of life, retaining not just bones but intricate biological details. As the team documented each layer of ice and sediment around the carcass, it became clear that this was a find unlike any other. Detailed examination revealed frozen organs and muscle fibers that retained cellular structure, a discovery that challenged assumptions about the limits of biological decay in permafrost. Histological analysis showed intact cell walls and preserved connective tissues, offering an unprecedented opportunity to study the anatomy of extinct megafauna in situ. Even enzymes and proteins, though denatured, retained structural traces that hinted at their original function. Scientists were astonished by the level of preservation, realizing that the ice had effectively suspended these creatures in time, creating an archive of biology that blurred the line between life and complete death. Radiocarbon dating placed the creature at tens of thousands of years old, yet the integrity of its cells suggested that life had persisted in a suspended, nearly imperceptible state. Layers of soil and ice surrounding the specimen were meticulously sampled, confirming that the timeline aligned with the late Pleistocene. The contradiction between age and biological preservation sparked questions about the processes enabling such endurance. Could extreme cold alone account for this anomaly? Or were there chemical or microbial factors at play that had slowed or temporarily halted decay? The answers remained elusive, adding to the aura of mystery surrounding the permafrost find. Within the preserved tissue, microbiologists detected living bacteria and viruses, organisms that had endured the extreme cold, raising questions about the resilience of life under conditions once thought lethal. These microorganisms appeared dormant, yet they could be revived under controlled laboratory conditions, suggesting that the permafrost acted as a natural incubator of suspended life. The discovery extended beyond curiosity, challenging existing knowledge of extremophiles and their capacity to survive in sub-zero conditions for millennia. It raised the unsettling possibility that other ancient life forms could persist in frozen environments worldwide, waiting silently in a state of near-lifeless dormancy. Independent laboratories confirmed the viability of these microorganisms, sequencing their DNA and observing metabolic activity, forcing scientists to confront the reality of life surviving deep time. Cross-institutional collaboration ensured that contamination was ruled out and that observed activity was genuine. In some cases, the bacteria displayed slow but measurable replication, demonstrating that frozen permafrost could maintain viable life far longer than previously assumed. These findings extended implications beyond paleontology, touching microbiology, astrobiology, and even theories regarding planetary habitability, all while underscoring the unnerving persistence of life against extreme odds. When samples were thawed in controlled environments, subtle chemical reactions and molecular signals indicated traces of ongoing biochemical processes, suggesting that the boundary between life and death was blurred. Researchers monitored shifts in pH, minor energy release, and enzymatic activity in ways that indicated the frozen tissue was not entirely inert. These signals were faint but reproducible, suggesting that cellular systems had been preserved in a kind of suspended animation. The phenomenon was unlike any known form of dormancy, challenging the assumption that biological systems inevitably collapse after thousands of years and compelling scientists to reconsider the resilience of life itself. Debates arose over the implications of reviving extinct species, with ecologists and ethicists weighing the potential consequences for modern ecosystems and the unforeseen ripple effects of reintroduction. Would resurrected megafauna be able to survive in today's altered landscapes, or would they become ecological burdens? Beyond ecological concerns, philosophical questions emerged. If life can persist in frozen time, to what degree do humans have the authority to reawaken it? These debates highlighted the moral and scientific responsibility inherent in studying permafrost preservation, reminding researchers that extraordinary discovery comes with equally extraordinary implications. Research teams began exploring the feasibility of cloning or reconstructing genomes from preserved cells, aware that technical hurdles were immense and success far from certain. DNA was often fragmented or chemically modified, requiring reconstruction using reference genomes and advanced molecular techniques. Even partial genome recovery could allow insights into evolutionary history and extinct species physiology. While some experiments succeeded in producing cellular models or synthetic tissues, the replication of an entire organism remained beyond reach. Each incremental step confirmed both the potential and the limitations of modern science when confronting the astonishing resilience of life locked in ice. The discovery reshaped understanding of survival in extreme conditions, hinting at the possibility that other long-extinct organisms may remain preserved in frozen repositories across the Arctic. Siberia, Alaska, and northern Canada hold countless untapped permafrost layers, each a potential archive of life lost to time. The phenomenon compelled researchers to rethink extinction as an absolute endpoint, suggesting that organisms might persist in a form imperceptible to conventional observation. This enduring life challenges assumptions about the fragility of biological systems and the permanence of death, opening the door to a world where the ancient past and present coexist in frozen harmony. Ongoing monitoring of thawed specimens revealed repeatable metabolic signals and resilience against decay, reinforcing the mystery of how life could endure for tens of thousands of years. Laboratory teams kept samples at precise temperatures, observing subtle chemical fluctuations that suggested activity without full revival. The patterns were consistent, confirming that the phenomenon was not a one-off anomaly or experimental artifact. As scientists documented each reaction and anomaly, the sense grew that permafrost preservation might be far more common and complex than previously recognized. A hidden layer of biological persistence quietly resisting the passage of millennia. Siberian permafrost emerges as a natural archive, storing not just the remains of ancient life, but also the hidden potential of revival, a testament to nature's capacity for endurance beyond human expectation. Each frozen specimen offers both insight and mystery, revealing the fragile yet astonishing persistence of organisms in environments once assumed to be lifeless. Researchers are left to ponder the broader implications, the line between extinction and survival, past and present, and the unknown capabilities of life under extreme conditions. The discovery is a window into a world where time slows, decay is suspended, and ancient life may await awakening. The frozen Earth holds them in a silent stasis, as if the past itself refuses to release the giants it has kept hidden for millennia. The Arctic Cold War listening stations. Signals of uncertain origin first drew attention decades ago, hinting at clandestine activity in the Arctic that official records only partially explain. Early satellite reconnaissance and sparse reconnaissance flights noted anomalies in areas supposedly devoid of significant human activity. Researchers and historians later pieced together fragments of evidence indicating that the region had once hosted an intricate network of listening stations designed with precision, secrecy, and technological sophistication far beyond what was publicly acknowledged. The discovery of these remnants revealed a world where extreme conditions, human ingenuity, and hidden agendas intersected in ways that remain difficult to fully comprehend. Engineers and military planners installed arrays of antennas and sensors in precise patterns, designed to detect activity far beyond the horizon, yet some functions remain undocumented. Massive radar dishes and slender towers once bristled against the Arctic skies, their placements dictated by both geography and the unknown logic of surveillance strategy. Every element, from cable routing to the orientation of arrays, suggested careful planning for operations that extended beyond conventional monitoring. Yet even among declassified schematics, certain devices remain unexplained, hinting at additional secret objectives whose records were either lost or deliberately suppressed. Inside the stations, control rooms were filled with banks of equipment whose purpose was classified, while unusual instruments suggested experimental monitoring that went beyond conventional radar. Oscilloscopes, receivers and recording devices hummed in silence once the stations were active, capturing streams of data that may never have been fully interpreted. Observers noted equipment that did not match any known standard, with peculiar displays and wiring that implied experimental functions. Technicians often recorded these anomalies in private logs, but official channels either dismissed or ignored them, leaving a legacy of unanswered questions about the true breadth of the station's capabilities. Declassified documents confirm the station's tracked aircraft and submarines, but several logs note anomalous readings that technicians could not reconcile with known targets. At times, screens would display echoes with no apparent source, or charts would spike inexplicably without warning. Some of these disturbances coincided with geomagnetic storms or solar activity, yet others had no natural explanation. The discrepancy between official purpose and operational anomalies created tension within the stations, as operators were trained to trust data, but often confronted phenomena that defied logic and challenged conventional surveillance theory. These anomalies included electromagnetic bursts, unexplained signal interference, and sudden surges that defied conventional explanation, leaving personnel perplexed and cautious. Instances of rapid frequency jumps, unknown waveforms, and intermittent pulses suggested that the Arctic environment itself could amplify or distort signals in ways not yet understood. Some reports even describe sequences of readings that resembled structured patterns, provoking speculation that the stations were detecting phenomena not entirely terrestrial. Each incident was meticulously recorded, yet the broader context remained inaccessible, leaving the anomalies shrouded in both mystery and classified secrecy. The culture of secrecy was absolute. Entire reports were destroyed or locked away, and personnel were sworn to non-disclosure, leaving gaps that modern investigators can only speculate about. Orders forbade discussion of anomalies outside assigned personnel, and many operators later claimed that their experiences were dismissed or never fully acknowledged. Classified channels ensured that even internal audits avoided certain topics, creating a situation where first-hand knowledge existed in fragments, memories, and obscure logs. This deliberate concealment compounded the enigmatic nature of the Arctic stations, leaving an incomplete puzzle for researchers attempting to understand their true purpose. A handful of former operators recount odd experiences, equipment that functioned autonomously, erratic lights, and voices or transmissions that never appeared on any official spectrum chart. Some described instruments activating without input, screens displaying patterns that vanished upon approach, and radios that intermittently transmitted unintelligible tones. These personal accounts, often declassified decades later, provide glimpses into a reality that the official records fail to capture. A place where human technology intersected with phenomena that were unpredictable and sometimes inexplicable. Each anecdote reinforces the notion that the stations were more than simple surveillance outposts. They were gateways to unknown activity, frozen in time. As technology advanced and the geopolitical focus shifted, stations were systematically abandoned, though some remote equipment was never fully deactivated, contributing to lingering mysteries. Satellite imaging has revealed that towers, antennas, and other structures remain partially intact, often pointing in directions that defy modern understanding of monitoring. Power systems, though mostly inactive, retain traces of energy distribution patterns suggesting intermittent or residual functionality. The abandonment process itself created questions. Were some devices intentionally left active, or was it merely a result of logistical constraints? The uncertainty adds a layer of suspense, hinting that some elements of the station's original purpose may still be operational. Recent satellite imagery and scientific surveys have revealed patterns and residual signals in the Arctic that suggest these installations may still interact subtly with the environment. Researchers note faint electromagnetic anomalies corresponding to former station locations, hinting that instruments or their materials could still influence surrounding magnetic fields. drones and aerial sensors have occasionally recorded interference or unexplained signal reflections in areas that match historical station sites. These findings provoke debate. Are the effects merely remnants of old technology, or could they represent lingering monitoring capabilities designed to persist beyond human intervention? Historians and physicists debate what the unexplained signals imply, including the possibility that some phenomena were never fully documented or understood, leaving a hidden layer of Arctic activity. The combination of extreme isolation, technological experimentation, and deliberate secrecy created conditions where mysteries could persist undisturbed. Some researchers speculate that the original designers may have anticipated long-term observation beyond official decommissioning, while others argue that the anomalies are natural consequences of operating sensitive electronics in extreme environments. Regardless, the Arctic stations remain enigmatic monuments to a period where science, military strategy, and secrecy overlapped. The Arctic holds these secrets in a silence that is both literal and symbolic, where the intersection of human ambition, technology, and isolation preserves enigmas decades after their creators departed. Structures that once hummed with purpose now lie still, but their residual effects ripple subtly through instruments, satellites, and environmental readings. Explorers, scientists, and historians alike are drawn to these sites, compelled by the unresolved questions and the faint traces of activity that refuse to dissipate. The tension between known operations and unexplained phenomena ensures that these stations continue to inspire curiosity, speculation, and awe. Decades later, faint electromagnetic whispers drift across the Arctic night, hinting that some messages were never intended for human ears. The Pole of Inaccessibility relics. Amidst one of the most forbidding reaches of Antarctica, explorers uncovered relics whose presence defied logic, suggesting human activity far beyond any documented expedition. These discoveries were first noted during routine surveys by research teams seeking coordinates for automated weather stations, yet the objects they found seemed entirely out of place. Metal fragments, weathered instruments, and other human-made items appeared scattered across the snow, sometimes partially embedded in the ice. The sheer improbability of encountering such artifacts in one of Earth's most isolated locations immediately raised questions about who had placed them, when, and for what purpose. The Pole of Inaccessibility is notorious for its extreme cold, relentless winds, and isolation, conditions that make any journey extraordinarily perilous and accidental deposition virtually impossible. Temperatures routinely plunge below -70 degrees Celsius, and storms can last for days, leaving anyone caught exposed to lethal risk. Supply lines are nearly non-existent, meaning that every expedition must be meticulously planned and executed, with no margin for error. These environmental realities underscore the peculiarity of the relic's presence, suggesting that their placement was deliberate, or that they arrived under circumstances that are otherwise unrecorded and deeply mysterious. The artifacts themselves were striking. Metal tools corroded by age, fragments of equipment, and objects of unknown origin, all remarkably preserved beneath layers of ice. Some bore markings that hinted at industrial manufacture, while others had no clear purpose or resemblance to known instruments. Their preservation was exceptional, given the extreme fluctuations in temperature and the abrasive nature of the ice over decades, or even centuries. Explorers noted that while some items appeared damaged or incomplete, others seemed almost intact, as though carefully shielded from the elements, raising further questions about their origin and journey. Historical records of Antarctic exploration offer few explanations, leaving gaps that raise questions about unrecorded journeys, lost teams, or entirely unknown visitors. While expeditions such as those led by Amundsen, Scott, and later Soviet and American teams are well documented, the relics do not align with any known mission timelines or cargo lists. Letters, journals, and official reports contain no references to these objects or the areas in which they were found. This absence of historical context amplifies the mystery, forcing researchers to confront the possibility that there were ventures into the continent's interior that were never officially recorded. Laboratory analysis revealed unusual compositions and weathering patterns, suggesting exposure to elements that conventional dating methods struggle to reconcile. Some metals showed oxidation inconsistent with known Antarctic conditions, while certain alloys indicated production techniques not widely used at the time of the supposed expeditions. Even trace chemicals on the surfaces suggested contact with substances unusual for a polar environment. These findings imply that the relic's origins may involve unknown supply chains, experimental materials, or journeys that challenge our understanding of human capability in extreme isolation. Remarkably, the relics endured ice pressures and seasonal shifts without significant deformation, an endurance that puzzled glaciologists and material scientists alike. Many items maintained structural integrity, despite centuries of compression and movement within glacial ice, hinting at either extraordinary material properties or conditions that prevented typical degradation. In some cases, items seem to have been partially buried and then exposed, as if natural forces had moved them sporadically rather than steadily, suggesting a pattern that could indicate human intervention or some unexpected environmental process. Speculation has ranged from mislaid expeditions to experimental polar missions, yet no theory fully accounts for the breadth and variety of artifacts discovered. Some historians argue that they may be remnants of early 20th century explorations whose records were lost in the chaos of war or neglect, while others propose that unknown scientific missions left instruments behind intentionally. The diversity of the relics, ranging from tools and mechanical parts to fragments that defy identification, makes any single explanation incomplete. Each artifact adds a piece to a puzzle that remains tantalizingly unsolvable, raising as many questions as it answers. Field reports describe explorers' astonishment upon encountering these objects, often questioning whether human error, natural displacement, or something entirely unexplained was at work. Notes from the first teams to document the relics describe disbelief, repeated verification of coordinates, and cautious excavation. Some explorers noted odd alignments or groupings, suggesting that the artifacts may have been placed intentionally rather than scattered randomly. Others speculated about the possibility of earlier polar travellers whose records had vanished, though no corroborating evidence exists. The combination of surprise, meticulous observation, and inconclusive answers enhances the chapter's tension and the sense of discovery. Beyond individual artifacts, the arrangement and scattering patterns hint at human intent or activity, creating a puzzle that merges survival, history, and mystery. Certain items appeared in clusters, while others were isolated, yet their relative positions suggested planning rather than chance. Patterns hinted at routes, supply caches, or temporary camps, though the absence of records means these remain speculative. Researchers studying the spatial distribution of relics consider factors like prevailing winds, ice movement, and potential human navigation strategies, seeking patterns that might reveal the story behind these frozen witnesses. Modern research continues to probe these relics with drones, sensors, and ice-penetrating radar, yet many questions remain unanswered, highlighting the enduring secrecy of the polar interior. High-resolution imaging and subsurface scans have identified anomalies in ice layers that correspond with known artifact sites, but the resolution is insufficient to fully interpret what lies beneath. Investigators hope to recover additional relics without disturbing the fragile environment, but each new finding only deepens the mystery. Even with modern technology, the pole of inaccessibility resists full comprehension, its frozen silence preserving enigmas that challenge human curiosity. The pole itself becomes more than a coordinate on a map. It is a silent witness to human endeavour and enigmatic traces that persist where no one expects them. Its isolation magnifies the improbability of human presence, while the artifacts it harbours testify to journeys that remain undocumented and poorly understood. For every relic unearthed, new questions arise about survival, intent, and history, leaving researchers suspended between the known and the unknowable. The region embodies both human ambition and nature's indifference, preserving mysteries in ice that may never fully reveal their origins. Encased in ice and silence, the relics remain as if the pole itself is guarding secrets of journeys that history has yet to acknowledge. The Tunguska ice layer disruption. Scientists were stunned when ice core samples revealed abrupt disruptions that seemed to mirror the energy of the Tunguska event, yet the layer's age and location offered no clear explanation. Researchers initially believed the polar ice would record gradual environmental changes, season by season, year by year, but instead they found sudden, sharp anomalies that interrupted centuries of steady accumulation. These disruptions suggested the arrival of an intense force capable of leaving a clear signature across kilometers of frozen layers. The unexpected correlation with Tunguska-like energy sparked immediate intrigue, though the distance between Siberia and polar collection sites only deepened the puzzle. Detailed examinations of the affected ice revealed sudden density fluctuations and fractures that defied the expected slow accumulation of polar layers over centuries. Scientists noted irregular compression, inconsistent crystal orientation, and even small voids that hinted at intense localized energy impacting the ice. These deviations were neither consistent with glacial flow patterns nor with known seasonal melting cycles. Advanced imaging revealed fractures extending across multiple strata, suggesting a force strong enough to disrupt the ice's natural layering, leaving physical traces that could be analysed decades later. Microscopic metallic fragments and unusual isotopes embedded within the ice hinted at a sudden high-energy phenomenon, challenging the assumption that the polar archive recorded only gradual environmental changes. The fragments, including tiny metallic spherules and rare elements, indicated the presence of extraterrestrial or high-energy terrestrial material. Isotopic ratios of oxygen and nitrogen within these layers deviated subtly from the surrounding ice, signalling sudden atmospheric changes. These findings reinforced the idea that the ice was not only a passive recorder of climate, but also a historical document of violent, abrupt events. Chronological analysis produced anomalies that refused to align with known events, suggesting that either the dating methods were incomplete or the disruptions originated from an unknown source. Ice core chronologies are normally precise, using seasonal layering, volcanic ash markers, and radiometric dating, but the layers in question presented inconsistencies. The anomalies appeared out of temporal sequence, appearing in strata older and younger than expected. Scientists debated whether the discrepancies were methodological errors, unexpected local effects, or evidence of a previously unrecognized high-energy event in Earth's atmospheric history. Researchers compared these findings to records of the 1908 Tunguska explosion and similar high-energy events, attempting to trace the signal across both time and thousands of kilometers of frozen terrain. While Tunguska flattened over 2,000 square kilometers of Siberian forest, its energy might theoretically have sent atmospheric shockwaves detectable far from the impact site. Yet, ice core anomalies recorded in polar regions seemed temporally and spatially disconnected, raising questions about whether additional, undocumented events had occurred. The possibility of repeated high-energy atmospheric events over centuries became a focus of debate among geophysicists and climatologists alike. Multiple hypotheses emerged, ranging from atmospheric meteoric debris to previously unrecognized geophysical phenomena, yet none fully accounted for the pattern and intensity observed in the ice. Some theorists proposed cometary fragments or asteroid airbursts, while others suggested extreme volcanic events or geomagnetic disturbances could produce similar signatures. Still, none of these explanations accounted for the combination of chemical anomalies, isotopic deviations, and structural fractures seen in the layers. The complexity of the evidence forced scientists to consider that the ice itself might preserve phenomena that defy conventional explanation. Comparative studies of ice cores from distant polar sites revealed similar anomalies, hinting that the effects of such catastrophic events may propagate more widely than previously understood. Researchers noted that ice from Greenland, Antarctica, and high Arctic locations displayed subtle but consistent disruptions, though each site showed unique intensity and chemical signatures. This suggested a global atmospheric mechanism, one capable of influencing ice accumulation across thousands of kilometers. The apparent universality of the phenomenon lent weight to theories involving high-energy atmospheric or extraterrestrial events rather than localized terrestrial causes. Technical difficulties complicated the investigation, as ice flow, chemical alteration, and potential contamination made it difficult to isolate and interpret the evidence accurately. Layers might be compressed, tilted, or partially melted, obscuring their original form. Drilling and sample handling had to be meticulously controlled to avoid introducing foreign materials or altering chemical markers. Even the most advanced laboratory techniques could not fully recreate the natural conditions that preserved these anomalies, leaving interpretation heavily dependent on inference and cross-site comparison. The implications of these disruptions extend beyond the poles, suggesting that Earth's ice layers may encode hidden records of catastrophic events that are otherwise absent from historical or geological archives. If the anomalies are indeed related to Tunguska-like energy, they point to a record of violent events spanning centuries, possibly revealing impacts, explosions, or atmospheric phenomena unknown to human history. Such findings challenge assumptions about Earth's environmental memory and raise the possibility that the polar ice holds evidence of events that could reshape our understanding of planetary hazards. Contemporary research employs isotopic mapping, high-resolution drilling, and radar imaging to probe the layers, yet the source, scope, and timing of these disruptions remain elusive. Teams continue to extract ice cores, refine chemical analysis techniques, and simulate potential energy sources in laboratory conditions. Despite technological advances, each discovery adds complexity rather than clarity, showing that the ice preserves evidence that is subtle, cryptic, and difficult to interpret. The challenge lies not only in detection, but in understanding what the layers truly represent. Each distorted layer stands as a frozen testament to sudden forces that humanity can detect but cannot fully explain, leaving scientists to reconcile observation with uncertainty. The anomalies are reminders that the Earth's polar archives do not merely record climate or environmental trends, they preserve traces of extraordinary events whose full context remains inaccessible. Scholars across disciplines debate whether these disruptions signal rare cosmic phenomena, undiscovered terrestrial processes, or even the lingering echoes of human history interacting with the environment in ways we cannot yet trace. Somewhere within the frozen depths, the ice holds memories of explosions that defy explanation and the chronological order of history itself. The Antarctic Subglacial mountain range. Seismic and radar scans revealed a hidden mountain range beneath Antarctica's ice, shocking geologists with its scale and alignment. The discovery emerged unexpectedly as teams analysing ice-penetrating radar data noticed repeated anomalies that could only be explained by solid peaks interrupting the otherwise smooth layers of ice. Unlike conventional Antarctic formations, these structures displayed a surprising linearity and consistency in height, hinting at a geological story that had gone unnoticed for millions of years. Researchers were confronted with the unnerving realization that the continent harboured massive terrain entirely invisible to traditional observation, a secret only now revealed through advanced technology. Peaks and ridges emerged in the data with jagged precision, cutting sharply through layers of ice that had long concealed them. The ice above, often several kilometres thick, had preserved these formations in suspended obscurity, allowing geologists to detect subtle variations in radar signal returns. Each reflection suggested abrupt changes in density and composition, consistent with mountain-scale structures, rather than the more gradual undulations typical of glacial flow. The clarity of these signals astonished researchers, hinting at a scale of topography hidden beneath the ice sheet that far exceeded any prior expectations for the region. Reflections suggested ancient rocks, both igneous and metamorphic, forming a composition entirely unexpected beneath the frozen continent. Geophysical models indicated that such formations could be remnants of long-extinct tectonic activity, or perhaps evidence of geological processes that Antarctica's modern ice coverage had long concealed. Petrographic studies, drawing on samples from exposed ridges elsewhere on the continent, support the idea that these hidden peaks could date back hundreds of millions of years, suggesting the Antarctic crust has preserved relics of an era before the ice sheets fully developed. The implications challenge assumptions about both continental stability and the history of polar tectonics. Some summits may rise as high as Europe's tallest mountains, a staggering revelation given the kilometres of ice above. These peaks, though invisible to the naked eye, exert measurable influence on the overlying ice sheets, redirecting flows and producing subtle pressure ridges detectable in satellite imagery. The contrast between the hidden peaks and the ice covering them provides a haunting reminder of the scale of what lies unobserved. A mountainous world existing in complete isolation, imperceptible yet monumental in its presence. Tectonic models struggled to explain the range, prompting theories from dormant rift zones to mysterious mantle plumes hidden beneath the crust. Scientists debated whether the formations could result from the stretching and breaking of Earth's crust long before Antarctica's glaciation, or if they reflected a previously unrecognized pulse of tectonic energy still influencing the continent. Each hypothesis carries profound consequences, potentially revising the understanding of continental drift, plate dynamics, and the forces that have shaped the Antarctic interior over geological timescales. The linear arrangement of the mountains stood out, defying the irregular patterns of other Antarctic ranges and hinting at forces yet unidentified. Unlike the jagged, erratic topography of exposed ranges, the subglacial peaks align in a way that suggests a hidden logic, a pattern that challenges conventional interpretations of crustal movement. Scientists consider whether this could indicate a long-forgotten rift valley, or perhaps the influence of ancient tectonic compression, but no single explanation fully accounts for the precision and extent of the alignment. Subtle shifts in glacier flow provided indirect clues as ice slowly contoured over the concealed peaks and valleys. Glacial movement, normally guided by gravitational gradients, exhibited anomalies when traversing these hidden formations. Pressure ridges, ice bulges, and minor crevasses hinted at obstacles below, allowing researchers to trace the peaks' outlines without ever directly observing the rock beneath. These indirect measurements reinforce the sense that the mountains are not only massive but also exert a tangible, though invisible, influence on the ice that conceals them. Controversy simmered within the scientific community, with some questioning whether radar artifacts could produce illusions of topography. Critics argued that ice layering, reflections, or signal distortion could create patterns resembling peaks where none exist. Proponents countered with cross-validation from seismic studies, gravitational measurements, and satellite gravimetry, demonstrating consistent evidence across multiple methods. The debate underscores both the difficulty and the importance of interpreting data from a landscape so thoroughly concealed, where even the most advanced technology must contend with the unknown. Earlier aerial surveys and ground-penetrating attempts had suggested anomalies, but only modern technology revealed the full, intricate scale of the range. Previous expeditions recorded unusual ice thickness variations and subtle glacial deflections, but lacked the resolution to identify distinct peaks. The integration of airborne radar, satellite measurements, and computer modelling now paints a more complete picture. A sprawling subglacial mountain range whose sheer magnitude and structure were previously unimaginable. This convergence of historical hints and modern confirmation deepens the intrigue surrounding Antarctica's hidden terrain. Advanced techniques, from satellite gravimetry to three-dimensional mapping, have begun to reconstruct the mountains, yet vast portions remain hidden. Even with high-resolution radar and gravimetric surveys, kilometers of ice obscure finer details such as exact peak heights, slopes, and internal geological composition. Researchers continue to refine their models, attempting to infer structure and composition from subtle gravitational anomalies and the patterns of overlying ice flow. Each new layer of analysis uncovers more questions than answers, emphasizing how much remains concealed in the frozen continent. Each new measurement reinforces the sense that Antarctica preserves colossal geological features, invisible yet profoundly influential beneath the ice. The subglacial mountains are a reminder that Earth's history is not only written in visible landscapes, but also hidden in spaces humans cannot easily access. They challenge assumptions about continental evolution, tectonic history, and the interplay between ice and rock, suggesting that the frozen continent may harbour secrets of a scale far beyond current imagination. Hidden under layers no human has touched, the mountains loom like a silent archive of Earth's forgotten history. The Greenland Viking DNA controversy. Unexpected patterns in ancient DNA extracted from Greenlandic remains have left historians and geneticists questioning the true extent of Viking presence in the region. What initially appeared as routine sequencing revealed discrepancies that did not align with established records of Norse settlement. Fragments of mitochondrial and nuclear DNA suggested lineages that should not have existed according to current historical models, raising questions about who might have traversed Greenland's icy expanses. These findings hint at a hidden chapter of human activity, preserved in the permafrost for centuries, and challenge assumptions about the limits of Viking exploration and survival in extreme conditions. Laboratories employing meticulous extraction protocols revealed sequences that hinted at lineages previously thought impossible in the Arctic environment. technicians worked under strict contamination controls, ensuring that the samples reflected genuine ancient DNA rather than modern intrusion. Sequencing revealed unusual combinations of markers, some closely related to Scandinavian ancestors, and others appearing more distant or unexpected. The precision of these results, combined with cross-validation from multiple labs, gave credibility to the notion that Greenland may have hosted human populations with genetic diversity far beyond what archaeology alone had suggested. Archaeological sites, from sod houses to abandoned outposts, provide tangible context for the genetic evidence, linking fragments of human history with frozen soil and permafrost. Excavations at known Norse settlements have yielded artifacts such as tools, timber and animal remains, providing a material record that can be compared with the DNA findings. In some cases, skeletal fragments preserved in cold soil offered the only direct connection to the people who once inhabited the region. These discoveries emphasize the interplay between physical evidence and molecular data, revealing a complex tapestry of human occupation that challenges simplified historical narratives. Several samples displayed ancestry markers inconsistent with established Viking settlements, suggesting either undocumented migrations or interactions with populations unknown to scholars. Some individuals carried genetic signals hinting at European lineages not previously documented in Greenland, while others appeared to share traits with groups from areas far outside the known Norse sphere. Such anomalies imply that movement across the Arctic may have been more frequent or diverse than previously assumed, and that small groups of explorers or settlers could have arrived and disappeared without leaving a clear archaeological footprint. Geneticists propose that these anomalies could indicate transient groups, rare survival events, or even lost branches of Norse explorers whose stories never entered the historical record. Perhaps small parties navigated the ice sheets and fjords, settling temporarily in remote valleys before vanishing due to environmental pressures. Alternatively, the genetic evidence may reflect sporadic contact with other populations, whether indigenous peoples or other explorers travelling across the North Atlantic. Each hypothesis underscores the unpredictability of human survival in Greenland's extreme climate, where harsh winters and limited resources would have dictated the lifespan of any settlement. Debate rages within the scientific community, as some experts argue that contamination or methodological errors could explain the unexpected results. Critics question whether cross-contamination with modern DNA or misinterpretation of degraded samples could have produced false signals. Supporters counter with detailed replication studies and radiocarbon dating that confirm the antiquity of the material. The discussion reveals not only the fragility of evidence in such remote environments, but also the tension between established history and molecular insights, highlighting how modern techniques can challenge long-held assumptions. Ancient texts and sagas recount voyages to Greenland, yet when aligned with the molecular data, gaps and contradictions emerge that historians struggle to reconcile. The Icelandic sagas, along with cartographic references from Norse explorers, describe settlements and voyages that match some of the known archaeological sites, but they cannot account for the anomalous genetic traces. These documents suggest a narrative of small, isolated communities, yet DNA hints at a more intricate story of population movement, survival, and perhaps fleeting contact with groups unrecorded in historical chronicles. The preservation of DNA in Greenland's extreme cold allows researchers to probe centuries-old samples, but also complicates interpretation as environmental factors may skew apparent timelines. Permafrost acts as a natural refrigerator, preserving delicate biomolecules that would otherwise degrade, yet freezing and thawing cycles can fragment DNA and introduce interpretative challenges. Scientists must carefully calibrate their models to account for these factors, combining genetic data with archaeological context and environmental studies to produce plausible reconstructions of past populations. Modern investigations, including new digs and advanced genome sequencing, are gradually uncovering a more complex picture of human occupation than previously assumed. Collaborative international projects now integrate high-resolution DNA analysis, isotopic studies of diet, and refined mapping of settlement patterns. These approaches reveal subtle clues, shifts in population structure over time, evidence of intermarriage or migration, and hints of cultural exchange that might explain the unexpected genetic signatures. Each new insight, however, tends to raise more questions, deepening the mystery surrounding Greenland's early inhabitants. Despite progress, each discovery seems to raise further questions, leaving the story of Greenland's early settlers incomplete and enigmatic. Were these genetic anomalies the result of small groups surviving in isolation, lost populations wiped out by climate, or evidence of voyages unrecorded in surviving texts? The contradictions between molecular evidence, archaeological data, and historical accounts suggest a narrative far more intricate than the traditional story of Norse settlement. Greenland's frozen landscape conceals more than ice and rock. It holds traces of human lives and migrations that science is only beginning to uncover. The interplay between evidence, interpretation, and the relentless Arctic environment underscores how much remains hidden beneath the ice and soil of Greenland. Each sample, each artifact, each subtle glacial anomaly contributes to a slowly emerging mosaic of a past that refuses to be fully known. Researchers are forced to navigate between scientific rigor and imaginative reconstruction, piecing together fragments that may ultimately tell a story radically different from the conventional history taught in classrooms. Even as the ice reveals fragments of its past, Greenland keeps its full human story tantalizingly out of reach, hinting at travelers and settlers who vanished without a trace. The Arctic methane crater fields. Mysterious depressions began appearing across the Siberian permafrost, deep cavities that seemed to form overnight and defied any clear explanation of their sudden origin. Photographs circulated of enormous bowl-shaped holes puncturing the frozen terrain, some wide enough to engulf trucks, leaving observers in disbelief. The regularity of their formation suggested more than random thawing or erosion, yet no immediate cause could be pinpointed. Local reports spoke of explosions or gusts of air, lending an almost supernatural quality to the phenomenon. Scientists, policymakers, and even oil exploration teams began to converge on the region, each seeking answers in an environment as unforgiving as it was mysterious. Investigators on the ground uncovered shattered layers of ice and soil, evidence of violent upheavals that left the surrounding tundra scarred and unsettled. The edges of the craters were jagged and sharp, suggesting rapid formation rather than slow erosion, while scattered debris indicated a forceful displacement of surface material. Observers noted that some craters had thrown frozen fragments dozens of meters away, resembling a miniature crater field one might expect from volcanic or explosive activity. Local herders and villagers described hearing strange thuds and feeling tremors underfoot, hinting that these formations were sudden and unpredictable. Each discovery prompted further study, as every new hole seemed to deepen the mystery rather than clarify it. Some craters extend tens of meters downward, revealing frozen strata in sharp relief, as though the Earth itself had been violently ruptured. Layers of permafrost, sometimes containing ancient plant material or ice lenses, were exposed as if torn apart from beneath, displaying a vertical history frozen over millennia. The contrast between the flat, undisturbed tundra and the jagged, cavernous craters heightened the sense that the region itself was being actively reshaped by unseen forces. Even more puzzling was the size variation. Some depressions were modest, while others dwarfed the tallest humans standing nearby, their depth exposing cross-sections of a frozen world rarely seen. The visual impact alone made it clear that a conventional explanation would be insufficient. The scientific focus quickly turned to methane trapped beneath the permafrost, with theories suggesting sudden gas expansion could trigger explosions capable of producing such massive depressions. Methane, a potent greenhouse gas, is known to accumulate under layers of ice and frozen soil, where pressure builds over centuries. When destabilized either by warming or mechanical disturbance, the gas could erupt violently, creating craters in a matter of moments. Researchers considered the implications. These eruptions were not just geological curiosities, but potential catalysts for atmospheric change, releasing methane directly into the Arctic sky. The link between thawing permafrost and these explosive events became central to understanding both the craters and the broader climate context. Analysis of the subsurface revealed extensive pockets of frozen gas interlaced with ice lenses, a precarious combination that builds pressure until release becomes inevitable. Ground-penetrating radar and seismic surveys indicated that these pockets were unevenly distributed, often beneath seemingly solid terrain, creating zones of hidden instability. In some cases, gas pockets were connected through narrow conduits, like subterranean pipelines, leading to sudden surface eruptions. Laboratory experiments and simulations confirmed that when ice caps over gas pockets crack, the pressure can release explosively, but the real-world scale observed in Siberia was far larger than anticipated. This combination of frozen soil and trapped methane provided a partial explanation, yet many questions remained unanswered. The distribution of the crater fields baffled experts, with dense clusters in some areas contrasting sharply with untouched stretches of permafrost nearby. Patterns seemed almost deliberate, as if a hidden hand had determined where explosions would occur. Scientists debated whether geological composition, historical ice layering, or underground waterways influenced the locations, yet no single factor accounted for the precise arrangement of these anomalies. In some areas, clusters appeared in perfect sequences, suggesting a chain reaction of pressure release, while isolated craters in distant areas implied random triggers. Understanding the spatial pattern became essential not only for scientific insight, but for predicting future eruptions. Climate specialists emphasized the potential danger, noting that each eruption releases potent greenhouse gases that could accelerate Arctic warming in ways that remain unpredictable. Methane is more than 20 times as effective as carbon dioxide at trapping heat in the atmosphere over short periods, meaning these explosions could amplify already troubling climate trends. Moreover, the sudden release could destabilize nearby permafrost, creating a cascading effect of additional craters. While the immediate risk to humans is low due to the region's remoteness, the environmental consequences are global. Each crater thus represents both a visible scar in the tundra and an invisible warning in the atmosphere. Advanced satellite imagery, drone reconnaissance, and thermal scanning offered unprecedented perspectives, allowing scientists to monitor new craters as they emerged. High-resolution imaging revealed subtle shifts in permafrost elevation, signs of gas accumulation, and even faint heat signatures preceding eruptions. Drones could hover over active sites, documenting the explosive force and dispersal of material with unparalleled detail. These tools allowed researchers to create near real-time maps of crater formation, helping to model both the mechanics of each explosion and the potential risks to surrounding areas. Technology became essential for understanding a process that is at once sudden, violent, and hidden beneath the Arctic ice. Several alternative explanations have been proposed, ranging from geothermal anomalies beneath the ice to buried river channels, yet none fully accounts for the scale and suddenness of these formations. Some geologists suggest that localized heat fluxes may weaken ice caps over gas pockets, while others propose that ancient hidden waterways could channel pressure to certain points. Meteorite impacts have also been considered, though the evidence for extraterrestrial triggers remains inconclusive. Each theory adds layers of intrigue to the phenomenon, reinforcing that the Arctic craters operate on principles still partially beyond our comprehension. Observations of similar features across other Arctic regions suggest that these craters may be part of a broader, largely unrecognized pattern of permafrost destabilization. In northern Canada, Alaska, and parts of Greenland, smaller depressions and explosive events have been documented, though none rival the size or frequency seen in Siberia. The implication is that the phenomenon may be systemic, reflecting changes in climate, permafrost composition, and subsurface gas dynamics across the circumpolar north. Understanding the Siberian craters may therefore provide insights into a much larger Arctic transformation, with consequences for ecosystems, atmospheric chemistry, and even human infrastructure. Even with detailed datasets and computer modelling, the forces behind these abrupt eruptions remain mysterious, challenging scientists to explain why they occur so unpredictably. Each new crater surprises researchers with its location, scale, or explosive energy, defying patterns suggested by prior observations. While laboratory simulations and theoretical models provide clues, the real Arctic terrain proves far more complex, influenced by centuries of ice formation, sediment deposition, and fluctuating temperatures. The craters are both a visible testament to natural forces and a reminder of the limits of our knowledge, signaling that the Arctic still harbours secrets too powerful to fully anticipate. The frozen expanse conceals violent eruptions that reshape the Arctic, leaving questions humanity may never fully answer. The Antarctic ice-penetrating radar structures. Unusual reflections traced patterns beneath the ice that no natural formation could easily explain, leaving experts struggling to interpret what lay hidden. The first images from deep penetrating surveys revealed shapes and layers that diverged sharply from expectations based on known geology. The anomalies appeared in regions long assumed to be relatively uniform, prompting teams to question whether the ice sheet concealed something far more complex than simple bedrock or sediment. Researchers noted angular patterns, abrupt shifts in reflective intensity, and linear structures that seemed almost deliberate, suggesting the ice may be hiding secrets that had never before been considered. Scientists quickly detailed how ice-penetrating radar operates, transmitting radio waves through thick ice and measuring reflections from subsurface layers. By calculating the travel time and strength of returning signals, glaciologists can construct detailed profiles of what lies beneath kilometers of frozen sheet. This technology has unveiled hidden lakes, river channels, and complex bedrock formations, but the unusual structures detected in recent scans defy easy classification. The data hinted at subglacial anomalies that appeared neither random nor fully explainable by conventional ice dynamics. Some scans displayed patterns resembling elongated ridges, abrupt angular depressions, and thin, reflective lines crisscrossing beneath the ice. These features did not align with natural drainage channels, sediment layering, or known tectonic faults, leaving observers perplexed. The geometric aspects were subtle but persistent, suggesting a system of formations rather than isolated quirks. The sheer scale of some anomalies, stretching across several kilometers, made them difficult to reconcile with current models of glacial flow and sediment deposition. Researchers attempted to correlate these radar findings with bedrock maps and seismic surveys, but the match was often incomplete or contradictory. Known mountains and valleys could not account for the patterns revealed, and many features appeared where no underlying topography had been previously recorded. The lack of congruence forced a reassessment of both radar interpretation methods and assumptions about Antarctic geology. Even minor discrepancies amplified the mystery, as no single explanation accounted for the complexity and scale observed in these hidden structures. Signal intensity variations revealed that certain formations reflected more energy than typical ice or sediment, suggesting differences in density or composition. Some regions appeared more rigid or compact, while others absorbed waves inconsistently, hinting at possible layers of unknown material or unusual ice stratification. These inconsistencies intensified scrutiny, as the radar signals implied that the Antarctic subsurface may contain pockets of anomalous composition not predicted by conventional studies. Each scan deepened the puzzle, forcing scientists to acknowledge that the ice sheet's hidden architecture was more intricate than previously imagined. Several anomalies intersected with subglacial lakes, channels, and networks of water under pressure, highlighting a potential relationship between liquid flows and the reflective patterns. Water under the ice sheet can alter radar reflections and create unexpected layering, but the structures persisted even after accounting for these hydrological effects. Some lines and ridges appeared to cross multiple lakes, suggesting that the formations were integrated across vast distances. The possibility that these structures interacted with both frozen and liquid layers added another dimension to their enigma. Even accounting for ice flow, thermal gradients, and known signal distortion, the unusual patterns remained consistent across repeated surveys. Radar specialists confirmed that artifacts from instrumentation or scanning errors could not explain the regularity of these features. The persistence of anomalies over multiple decades of observations emphasized that these structures were not temporary, seasonal, or artificial errors, but permanent characteristics of the subglacial environment. Researchers faced the unsettling reality that much of Antarctica's interior remains a domain of genuinely unknown forms. Various natural explanations have been proposed, including tectonic shifts, buried valleys, sediment accumulation, and ice folding. Each theory accounts for some aspects of the radar readings, but fails to explain others, leaving critical questions unanswered. For example, some linear features are far too precise to be solely tectonic, while isolated depressions occur where sediment deposition is minimal. The partial explanations highlight both the ingenuity of geologists and the stubbornness of the Antarctic landscape in concealing its full story. Repeated radar scans have confirmed that the anomalies remain remarkably stable over time, further reinforcing their legitimacy. Their consistency implies that they are intrinsic to the ice sheet's structure rather than fleeting phenomena, Comparative studies across other regions of Antarctica suggest that these hidden formations may not be isolated, but part of a broader system of subglacial features yet to be fully understood. Each new survey seems to deepen the mystery rather than reduce it, hinting at a continent still filled with secrets beneath its frozen surface. Broader surveys reveal additional anomalies in distant Antarctic regions, some resembling those first detected, others introducing new patterns entirely. The combination of repetition and divergence across the continent suggests that multiple processes, geological, hydrological, and perhaps previously unknown, may be responsible. Scientists acknowledge that full comprehension of these structures could require decades of data, advanced modelling, and a willingness to accept that the ice sheet holds surprises no current theory fully anticipates. The continent, in essence, guards its history in layers of ice both familiar and strange. Ultimately, these ice-penetrating radar structures serve as a reminder that, even in an era of advanced technology and global research, the Antarctic interior retains profound mysteries. Every scan, survey, and field expedition exposes only fragments of a hidden world, leaving researchers with more questions than answers. These structures are both a scientific challenge and a humbling signal that some secrets of the planet may remain forever obscured beneath ice that has persisted for millions of years. The deeper one probes, the more the continent resists total understanding. Deep within the frozen expanse, Antarctica conceals structures that may never be fully explained. The Franklin Expedition Body Preservation. What remained of the Franklin Expedition crew astonished investigators, bodies remarkably intact despite more than a century beneath Arctic ice. When explorers finally reached the sites where skeletal fragments and frozen corpses had lain for decades, they encountered a scene that seemed to challenge the very principles of decomposition. Limbs were stiff yet preserved, and in some cases soft tissue had survived in ways scientists could scarcely explain. The extreme cold had arrested the usual chemical and biological processes, but not all aspects of preservation could be accounted for by temperature alone, leaving a silent, eerie testament to the Arctic's peculiar hold on life and death. In 1845, two Royal Navy ships, the HMS Erebus and HMS Terror, embarked on a mission to chart the Northwest Passage, vanishing without a trace and leaving only whispers of their fate. The men aboard were highly trained, equipped for long-duration voyages, yet they disappeared into the icy void, leaving behind a trail of unanswered questions. Contemporary reports hinted at dwindling supplies, illness, and extreme cold, but the scale of their disappearance only became clear decades later, when explorers began uncovering artifacts, skeletal remains, and preserved bodies buried in the unforgiving permafrost. The Arctic itself seemed to have claimed the expedition, preserving remnants while obscuring the story. Early search parties found scattered equipment, abandoned tents, and skeletal remains, each discovery hinting at a slow, frozen unravelling that defied normal decay. Inuit testimonies occasionally mentioned skeletal figures emerging from snowdrifts or floating in ice floes, accounts that were long dismissed but later corroborated by modern archaeological work. Even fragments of clothing and personal items had been preserved, frozen in a near-pristine state that allowed historians to reconstruct aspects of daily life aboard the doomed ships. Every discovery deepened the sense of a puzzle, where the harshness of the Arctic had simultaneously destroyed and preserved, leaving traces that challenged conventional expectations. Modern forensic examinations revealed astonishing preservation of soft tissues and bone structures, suggesting conditions that temporarily suspended natural decomposition. CT scans and microscopic analysis showed collagen fibers intact in ways rarely seen outside cryogenic preservation, while hair and fingernails remained surprisingly well formed. Some bodies still bore the subtle contours of muscle, and in rare instances, internal organs were partially preserved. These findings prompted speculation about the interactions between freezing temperatures, the chemical composition of human tissue, and microbial activity, creating a new field of study at the intersection of polar science and forensic anthropology. The relentless cold and permafrost created an environment where decay slowed dramatically, yet some features of the remains remained inexplicably supple and lifelike. Freezing normally halts bacterial activity, but the persistence of pliable tissue in certain areas suggested an additional, unknown factor at play. Ice crystals, soil composition, and microclimatic variations may have combined to form localized preservation pockets, but no clear pattern emerged. The bodies seemed to exist in suspended animation, a frozen echo of the final days of the crew, allowing researchers a window into a world long vanished, yet not entirely erased by time. Chemical and isotopic analysis uncovered high lead levels, scurvy, and signs of starvation, raising questions about how physiological stress might have influenced the unusual preservation. Lead from canned provisions may have weakened organs, while malnutrition and vitamin deficiencies accelerated mortality. Yet the preservation of soft tissues despite these stresses remained baffling, suggesting that environmental factors outweighed internal physiological decay. Examining bone density and tissue composition revealed anomalies that modern medicine could not fully explain, further blurring the line between natural decomposition and the Arctic's almost supernatural capacity to arrest time. Other Arctic-era remains failed to exhibit the same remarkable preservation, emphasizing how extraordinary the Franklin bodies truly were. Explorers and researchers studying contemporaneous shipwrecks or isolated burials found skeletons reduced to dust, yet here, the bodies of men who had died in the mid-19th century retained anatomical integrity in multiple dimensions. The disparity raised difficult questions. Why had some permafrost sites achieved this suspended state while others had not? Investigations suggested that microenvironmental conditions, such as insulation by snow, ice layering, and air pockets, could be responsible, though no comprehensive explanation existed, leaving scientists cautiously intrigued. Accounts from Inuit communities and expedition diaries hint at mysterious behaviours and deaths that add human intrigue to the scientific anomaly. Stories described crews abandoning ships under duress, wandering across ice fields, and succumbing to exhaustion and starvation in ways that seem almost ritualistic in their inevitability. These accounts, combined with skeletal evidence, revealed signs of cannibalism, trauma, and illness, details that underscore the human suffering underlying the preservation mystery. The juxtaposition of such grim historical context with the frozen, almost serene state of the remains created a tension that scientists and historians continue to grapple with as the bodies tell a story that words alone cannot convey. Advanced imaging and DNA sequencing continue to reveal new details about the crew, their illnesses, and subtle anatomical features preserved beneath the ice. Mitochondrial DNA analyses help trace lineages, while forensic imaging reconstructs facial structures, offering glimpses of individuals long thought lost. Tissue sampling provides insight into diet, pathogens, and environmental exposure, creating a scientific portrait of men suspended in time. Each new technique reinforces the Arctic's dual role as both preservative and obliterator, preserving some aspects of life while erasing others, leaving only fragments of truth to be painstakingly reconstructed. No single explanation accounts for why some bodies remained intact while others succumbed to decay, leaving a persistent riddle for researchers. Variability in burial conditions, ice composition, microbial activity, and exposure to sunlight might contribute, yet no model fully reconciles the evidence. Forensic teams continue to test hypotheses, using advanced thermodynamic modelling, permafrost simulation, and chemical analysis. Each discovery opens new questions, emphasizing the unpredictable nature of Arctic preservation and reminding investigators that even the most detailed studies are subject to the whims of extreme environments that have claimed generations of explorers before. Each fragment of preserved tissue serves as a reminder of the Arctic's power and the fragile boundary between life and the frozen void that claimed the expedition. Bones, hair, and occasionally skin stand as silent markers of human endurance and tragedy, reflecting both the ingenuity and vulnerability of those who ventured into the unknown. The remains are not merely relics, they're active participants in a dialogue between history and science, asking questions that modern researchers can study but not fully answer, holding their secrets in the deep, cold silence of the Arctic. The Franklin expedition's frozen corpses endure as silent witnesses to a journey that science has yet to fully understand. The polar magnetic drift acceleration. The relentless march of Earth's magnetic North Pole across the Arctic has become one of the most unsettling phenomena in modern geophysics, a drift that refuses to slow and instead shows signs of accelerating in ways scientists still struggle to fully explain. For centuries, navigators relied on the relative stability of magnetic north, But over the past several decades, that once reliable reference point has undergone a bewildering transformation, defying long-held assumptions about the steadiness of Earth's magnetic field. Surveys from ground stations and satellites revealed shifts of tens of kilometers per year, suggesting the pole's trajectory possesses a mysterious momentum. This chapter examines the acceleration of the polar magnetic drift, a phenomenon rooted deep within the planet yet manifesting in the Arctic. By the early 20th century, explorers in the high Arctic documented the magnetic North Pole's position and its slow southeastward drift across northern Canada. These measurements, painstakingly obtained with declinometers and celestial observations, hinted at motion but suggested a steady, predictable pace. With the advent of space-based instruments in the mid-1900s, scientists gained the ability to track magnetic field changes with unprecedented precision. What emerged from that surveillance was not the gentle meander once assumed, but a startling quickening, as if the magnetic pole had abandoned its ancient course and embarked on a hasty migration towards Siberia. Data from the World Magnetic Model, a global representation updated every 5 years to support navigation, showed the pole's velocity increasing from around 15 kilometers per year in the early 20th century to over 55 kilometers per year by the early 2000s. These numbers, maintained by agencies such as the US National Centers for Environmental Information, revealed a shift that seemed anything but gradual. What had been an incremental wander grew into a surge, compelling scientists to revise predictive models more frequently and raising questions about the processes driving the acceleration. At its core, Earth's magnetic field is generated by convection within the liquid iron outer core, a churning sea of metal 3,000 kilometers beneath the surface. That engine drives the geodynamo, producing the field that envelops the planet. Variations in flow, temperature, and composition can alter the magnetic field structure on timescales from years to millennia, and the recent drift acceleration suggests that something in this hidden realm has changed. Satellite missions like the European Space Agency's Swarm constellation have provided detailed measurements of these fluctuations, allowing scientists to explore how core processes manifest at the Arctic surface. The magnetic North Pole's path does not align neatly with any simple gradient or force. Instead, its trajectory over recent decades of theses traced a curious arc northward from Canada and then turned with increasing speed towards Siberia. At times, the movement appears to buckle, as if responding to unseen perturbations deep within Earth. Localized magnetic flux patches at the core mantle boundary could act as hidden drivers, tugging at the field lines in unpredictable ways. Yet no consensus exists on why these changes have intensified, or why the pole's motion accelerates so abruptly. The drift is not merely an academic concern. Systems that depend on magnetic reference points must adapt to the field's capricious behavior. In 2019, the World Magnetic Model required an unprecedented out-of-cycle update when the pole's movement outpaced predictions, potentially causing navigational errors for aircraft and maritime systems. Pilots, ship captains, and even smartphone applications rely on accurate magnetic data, and when the model fails, the consequences ripple outward into everyday technologies. That such infrastructure must adjust to a shifting pole underscores the reach of a phenomenon rooted deep beneath Earth's surface. Scientists continue to debate why this acceleration occurs. Some hypothesize that flux patches at the edge of the outer core, growing or waning over decades, alter large-scale field structures. Others point to interactions between the core and lower mantle, where thermal anomalies could influence flow patterns. A third possibility is that the field is undergoing a long-term excursion or approaching a polarity reversal, a dramatic flip of magnetic north and south that has occurred repeatedly in Earth's history. Geological records suggest these reversals unfold over thousands of years, but the current rapid drift has unsettled those monitoring it closely. The Arctic landscape itself seems to mirror the instability above it. Permafrost that held for millennia now thaws, revealing ancient terrains and relics long buried beneath ice. In this setting, the magnetic pole's flight towards Siberia feels almost prophetic, as if the frozen extremities respond to forces beyond human understanding. Scientists on icebreakers and in remote observatories record data against a backdrop of cracking sea ice and shifting horizons, aware that their efforts to understand the geodynamo intersect with a broader story of planetary transformation that may never be fully grasped. Despite growing data and increasingly sophisticated models, profound uncertainty remains. Tools developed to forecast the pole's position must be recalibrated with greater frequency, highlighting the phenomenon's unpredictability. Some researchers caution that Earth's magnetic field has always been dynamic and that rapid fluctuations are part of natural variability. Yet the sustained pace and apparent acceleration challenge simple explanations, hinting at processes within Earth only partially glimpsed through observation, as if the planet's interior possesses secrets deliberately concealed from human measurement. Migratory species such as birds, sea turtles and whales use Earth's magnetic field as a guide, a biological compass that steers seasonal journeys. As the field fluctuates and the magnetic North Pole roams with increasing velocity, these navigational cues could become misaligned. While many species possess alternative guidance systems, the potential for disorientation adds a living dimension to the mystery, suggesting that even the natural world senses the instability below. This intersection of planetary physics and biology emphasizes that the polar magnetic drift is not only a geophysical oddity, but a phenomenon with far-reaching implications. Ultimately, the polar magnetic drift acceleration reshapes our understanding of Earth's interior. The pole no longer drifts as a slow wanderer, it has become a symbol of geological restlessness, a marker of forces hidden far beneath the ice yet capable of altering ecosystems, technologies, and human perception. Geophysicists continue to refine models and gather measurements, seeking patterns that might illuminate the cause of the acceleration, but each new insight seems only to deepen the enigma, leaving the Arctic a silent witness to a mystery that is still very much alive. The pole's relentless rush seemed to whisper that Earth, though familiar to us on its surface, still harbours secrets capable of upending everything we think we know about our planet. The Wrangel Island dwarf mammoths. Mist hung low over the tundra of Wrangel Island, concealing the bones and tusk fragments that whispered of a population of mammoths surviving far beyond their supposed extinction, a discovery that forced scientists to reconsider the timelines of Earth's great Ice Age giants. Most of their kind had vanished from the mainland at the end of the last glacial period, retreating with the ice and disappearing from the fossil record by roughly 10,000 years ago. Yet here, on this isolated Arctic landmass, descendants persisted for another 6 millennia. What allowed these creatures to linger so long after their cousins disappeared remains a mystery woven into the frozen soil and tangled roots of Arctic vegetation. While the vast herds of the mainland died out as climates warmed and ice sheets retreated, a remnant group of woolly mammoths became trapped on Wrangel Island when rising sea levels severed the land bridge that once connected it to Siberia. Cut off from the ebb and flow of migrating herds and human hunters alike, these survivors found themselves in a world apart, where millennia passed like rhythmic tides against the solitude of Arctic shores. Those earliest arrivals were typical in size, but over generations they became smaller, their bodies adjusting to island conditions. Their reduced stature fell within the known range for mainland mammoths, yet their prolonged survival in isolation placed them outside the expected evolutionary narrative. Archaeological surveys in the mid-20th century uncovered fossilized tusks and teeth nestled in permafrost sediments, evidence that mammoths walked this land long after their extinction elsewhere. Radiocarbon dating of these finds revealed ages as recent as around 4,000 years ago, placing these creatures in a time when ancient Bronze Age civilizations were flourishing thousands of kilometers to the south. For perspective, monumental stone pyramids had already pierced the Egyptian skies centuries before these last mammoths faded from the Arctic landscape. These surprising dates rippled through scientific circles, challenging assumptions about extinction as an abrupt uniform event across species ranges. Remarkably, the mammoths of Wrangel Island displayed physiological differences compared to their mainland forebears, traits long attributed to island dwarfism. In many island ecosystems around the world, large mammals tend to shrink over generations as limited resources and geographic isolation favour smaller body sizes. Though their size may not have been dramatically smaller than some mainland counterparts, this population's unique morphology hints at adaptive responses to the sparse tundra vegetation and seasonal extremes they endured. Their diminished height and bulk were not signs of weakness, but rather of resilience. Strategies that allowed them to subsist in a biome that fluctuated between harsh winters and surprisingly fertile summers. The windswept tundra, dotted with mosses, sedges and dwarf shrubs, formed an ecosystem that seemed almost engineered for endurance, offering enough sustenance to sustain a species that had disappeared everywhere else. Analyses of bone chemistry suggest that Wrangel's vegetation remained stable and rich in nutrients for thousands of years, providing a steady diet that contrasted with the rapidly changing habitats elsewhere after the Ice Age ended. Without predators, including humans, the mammoths grazed undisturbed, their days marked by the slow rhythm of Arctic seasons and the ceaseless march of ocean tides against the island's rocky shores. Despite this seeming haven, genetics played a curious role in the story of these last mammoths. DNA extracted from permafrost-preserved specimens shows that the population originated from only a handful of individuals after becoming isolated, a severe bottleneck that reduced genetic diversity but did not doom them outright. Within a surprisingly short span of about 20 generations, the population rebounded to an estimated 200-300 individuals. Scientists found evidence of low genetic diversity consistent with inbreeding, but the most harmful mutations were gradually purged over time, allowing the population to remain stable for thousands of years before their final disappearance. As centuries turned to millennia, the mammoths on Wrangel Island adapted to their insular world, but the question of why they eventually vanished hangs like a riddle in the Arctic air. Earlier hypotheses had blamed genetic meltdown, the accumulation of deleterious mutations that would weaken a small population over time, yet newer genomic analyses suggest this may not fully account for their end. Other research points to environmental episodes, perhaps a series of extreme weather events or abrupt shifts in freshwater quality due to bedrock weathering, that could have stressed the population beyond recovery. No consensus has emerged, and the lack of a clear killer event makes their decline all the more enigmatic. Notably, the earliest evidence of human presence on Wrangel Island emerges only shortly after the last known mammoths disappeared, indicating that these iconic beasts and people likely never encountered each other. Stone tools and hunting camp remnants dating to roughly 3,600 years ago attest to human arrival after the mammoth's extinction, suggesting that hunting was not their undoing here. This contrast sharpens the mystery. On the mainland, human predation contributed to megafauna declines, yet here, on an isolated Arctic outpost, the mammoths endured in the absence of people, only to vanish before sustained human settlement took hold. The island itself is a testament to contrasts, where the bones of these great mammals now lie among a rich assemblage of Arctic fauna, including polar bears, seals and lemmings that thrive in the tundra's delicate web. Wrangel Island today supports one of the highest densities of polar bear dens in the world, and an astonishing diversity of plant life, double that of many similar Arctic regions, a legacy of micro-habitats that have persisted through climatic shifts. Yet among this thriving biosphere, the silence of the mammoth past echoes like a cautionary whisper, a reminder that even long-hidden populations eventually confront forces beyond their adaptation. Despite decades of research, profound uncertainty remains about the final chapters of the mammoth story on Wrangel Island. Some scientists argue that catastrophic events, perhaps sudden ice storms, food supply collapses or abrupt changes to water chemistry, played a decisive role in their demise, sharply curtailing their long tenure on this Arctic sanctuary. Others emphasize the gradual erosion of resilience in small, isolated populations, where even mild environmental perturbations can tip the balance toward collapse. In either view, the disappearance of these last mammoths underscores a paradox. They survived when all odds seemed stacked against them, only to be claimed by circumstances that leave no clear fingerprints. Studying these isolated survivors reshapes our understanding of adaptation, isolation and extinction, hinting at patterns in nature that remain just out of reach of modern science. The mammoth's long isolation teaches that life's persistence can exceed human expectations, clinging to refuges that defy climatic upheaval and anthropogenic pressures. Yet their eventual extinction also teaches that even the most resilient populations can succumb to abrupt change, a lesson that resonates today as global climates shift and species struggle to find safe harbours. In this Arctic crucible, the legacy of the Wrangel Island mammoths endures as both marvel and mystery, a chapter of Earth's history that should not have existed yet, did for far longer than anyone imagined. On the far edge of the Arctic, the last traces of these dwarf mammoths endure, a silent testament to life's stubborn refusal to vanish entirely. The Arctic ghost stations of the USSR. A low sun reflected off the ice as frost-coated buildings emerged from the snow, revealing a station frozen in time, abandoned with instruments still humming beneath their icy shells. Metal doors hung crooked. Windows were streaked with frost, and desks remained cluttered with papers partially encased in ice. It was as if the scientists had vanished mid-task, leaving behind a world where human presence lingered, but life itself had disappeared. The Arctic wind swept through corridors, carrying the scent of machinery and varnish, amplifying the impression that this was a place where something vital had been left unresolved, preserved in a frozen moment. In the decades following World War II, the Soviet Union launched an ambitious program of polar research, constructing remote outposts across the Arctic to monitor climate, geomagnetism, and other phenomena that fascinated both scientists and military strategists. These stations were logistical marvels, requiring years of preparation, thousands of tons of supplies, and careful planning to sustain even a small crew through the endless polar night. Yet, for all the organisation and foresight, some stations were abandoned suddenly, leaving behind equipment still operating and records that suggested work had been halted abruptly rather than concluded. Satellite images and aerial surveys have since revealed clusters of derelict structures scattered across remote expanses, each bearing the marks of hurried departure yet untouched by the passage of years. From above, the frozen stations resemble ghostly geometric shapes, isolated rectangles and squares interrupted by antennae jutting toward the grey sky. Snow and ice obscure pathways that once linked laboratories, barracks and storage facilities, while the occasional exposed pipe or twisted metal fragment hints at human activity abruptly stopped. Even decades later, the stark outlines provoke questions about the lives that once animated them. The shifting Arctic terrain conceals and reveals remnants of human endeavour, exposing jagged metal frameworks and ice-streaked windows that hint at sudden evacuation. Permafrost can preserve artefacts with remarkable clarity, yet it also moves over time, bending and breaking wooden structures and twisting metal supports. These processes sometimes reveal hidden corners of stations, doorways once blocked, stairwells partially filled with snow, or rooms whose functions remain uncertain. Observers are left to imagine the decisions that led people to abandon these spaces and whether some hidden urgency drove them from one day to the next. Inside the stations, explorers have found desks littered with frozen papers, thermometers still threaded through ice-covered tubes, and the faint odour of varnish and machinery lingering in frigid corridors. Laboratory equipment is often left in place, some of it still connected to power sources or wired into monitoring systems. Scientific instruments, designed to endure harsh climates, stand like sentinels pointing at the sky or ice, waiting for hands that will never return. Personal effects, notebooks and maps are preserved as if someone simply stepped away, giving modern visitors the unnerving sense of interrupted human life in a land both remote and unforgiving. Some logs describe routine measurements of temperature, wind, and magnetic fields, yet others include entries that are brief, cryptic, or abruptly halted, leaving traces of unfinished experiments scattered across the pages. One log may contain meticulous data from daily geomagnetic readings, while the next abruptly notes, "Observations terminated, unknown interference." Other entries describe mechanical failures, sudden blizzards, or equipment anomalies that were never fully explained. The gaps in the records, combined with the sudden cessation of writing, reinforce the sense that something unknown forced the teams to leave without completing their work. The personnel who once occupied these outposts vanished as mysteriously as the work itself, with official records offering little explanation for the sudden departures. Some stations were evacuated after routine inspections found no structural damage or external threats, leaving modern investigators to question whether internal crises, environmental phenomena, or unexplained events had precipitated the exit. In many cases, team rosters abruptly end, suggesting that personnel left simultaneously, abandoning personal belongings and unfinished experiments. The exact reasons remain obscured by decades of secrecy and extreme isolation. Scholars and scientists have suggested explanations ranging from extreme weather events to bureaucratic directives, but none fully account for the eerie preservation of functioning equipment and unclaimed records. Arctic storms could certainly destroy structures, yet the stations were often intact, with snow and ice acting as a protective shell rather than a destructive force. Administrative orders might explain closures, but would they also leave advanced monitoring devices operational, as though the instruments themselves had been trusted to continue work alone? The contradictions only deepen the mystery. Modern researchers walking the frozen halls often encounter instruments that seem poised for action, corridors where frost glitters like glass, and shadows that flicker in the Arctic light, evoking a presence long gone. Ambient sounds, wind rattling metal, ice cracking underfoot, amplify the feeling that the stations are not entirely lifeless, that some memory of human occupation clings to the walls and machinery. Even trivial items, like a half-filled coffee cup or a note left on a table, appear charged with tension, suggesting that some unresolved story lingers, frozen into the Arctic landscape alongside the stations themselves. The tension of human ingenuity against relentless polar desolation is palpable, with abandoned laboratories whispering of incomplete discoveries and knowledge glimpsed but never fully realized. The contrast between the effort required to operate these outposts and their sudden, unexplained abandonment highlights the unpredictability of life in extreme isolation. These stations are simultaneously monuments to human achievement and reminders of vulnerability, standing as silent witnesses to decisions and events that will never be fully reconstructed. These ghost stations remain as enigmatic as the Arctic itself, their frozen halls offering both glimpses of historic scientific work and a lingering sense of unanswered questions. The juxtaposition of human presence, advanced technology, and utter remoteness creates a paradox. Life and purpose once existed here, yet nature and circumstance have reclaimed the space, leaving only traces and speculation. For explorers and historians alike, they're enduring symbols of mystery, resilience, and the unknown forces that operate in the world's most extreme frontiers. Amid the unending white of the polar expanse, the silent corridors of these stations seem to guard truths that no living witness has yet managed to uncover. The Antarctic neutrino source events. Unexpected spikes of energy began appearing in the neutrino detectors, sequences of signals that confounded even the most experienced researchers and hinted at forces beyond conventional understanding. These bursts did not align with predicted cosmic patterns or previously catalogued sources, and their arrival angles suggested something entirely unanticipated. Scientists monitoring the data initially suspected instrument error, yet repeated calibrations confirmed the readings. In the sterile glow of Antarctic laboratories, the sensors reported events that should not exist, pushing teams to confront phenomena that could challenge the foundations of particle physics while remaining utterly invisible to the naked eye. These sensors, embedded deep within the clear Antarctic ice, are designed to observe particles so elusive that trillions pass through the human body each second unnoticed. Installed in cubic kilometre arrays, they rely on the Cherenkov effect, detecting the faint flashes of light produced when neutrinos interact with ice molecules. Yet some of the detections carried energies and trajectories that defied expectations, suggesting sources that could not be reconciled with current astrophysical models. For physicists, the anomaly was electrifying and disconcerting, a signal from nature that hinted at unseen mechanisms or perhaps a new frontier in understanding matter and energy itself. Each burst is fleeting, lasting mere fractions of a second, yet the pattern of arrivals implies a source that is localized and unusually precise. Unlike the random background of cosmic neutrinos, these events cluster in ways that resist statistical explanation. Some originate from directions seemingly beneath the ice, while others appear to have paths that intersect unpredictably, suggesting either unknown physical processes or a signal distorted in ways scientists have yet to understand. For months, teams documented every interaction, every flash of light, with growing unease at what the ice itself might be concealing. Scientists first noticed the anomalies when routine analysis revealed particles coming from angles inconsistent with established astrophysical trajectories. The initial reports were met with skepticism. Instruments might misfire, or software could misinterpret readings. Yet subsequent verification across multiple sensors confirmed the data. The energy levels recorded were sometimes orders of magnitude higher than typical background neutrinos, and the spatial patterns suggested origins close to the Antarctic interior a notion that seemed impossible given the known behaviour of such elusive particles. Each dataset deepened the puzzle. Clusters of detections formed intermittently, energy peaks appearing sporadically yet repeatedly over weeks. The intervals were irregular, yet some patterns hinted at a rhythm that defied explanation, as if the source followed a hidden schedule. These sequences captured the attention of both the experimental teams and theoretical physicists, who pored over months of logs and charts to find correlations. Despite exhaustive cross-referencing, no cosmic event, solar flare, or atmospheric disturbance could account for the anomalies, leaving a profound sense that something entirely unknown was manifesting deep within or above the Antarctic ice. Laboratory simulations, calibration checks, and software audits all failed to reveal faults, forcing researchers to accept the possibility that the signals were genuine. Teams verified timing systems, optical sensors, and data pipelines, yet the burst persisted. The instruments functioned as designed, yet produced results outside predicted parameters. This forced a reconsideration of assumptions about particle behaviour, detector interaction, and even the environment itself. The anomaly became a focus of intense curiosity, the perfect intersection of extreme location, advanced technology, and data that refused to conform to established scientific understanding. The anomalies challenged established theories of particle physics, raising questions about processes that may exist in nature but have never been observed before. Could there be a class of neutrinos or exotic particles behaving differently under polar conditions? Might there be local phenomena within the ice or the Earth's crust that generate these high-energy events? Each question seemed to open several more, creating a cascade of theoretical speculation that scientists could not ignore. The Antarctic neutrino detections became a rare example where observation preceded explanation, leaving fundamental gaps in the framework of physics. Monitoring teams, working under the unrelenting Antarctic night, scrutinized each incoming dataset, aware that even a single overlooked anomaly might hold the key to understanding the source. The cold, silent stations amplified the focus, with instruments illuminating the otherwise darkened ice caverns. Scientists worked in shifts, often consulting digital models of particle trajectories, attempting to triangulate sources that might exist somewhere beyond observation. Every new detection was logged, every outlier analysed, feeding a growing sense that the ice itself might be participating in phenomena that humans had yet to decipher. Some researchers hypothesize that the Antarctic ice may influence particle behaviour, refracting or amplifying signals in ways still poorly understood. The clarity of deep ice, combined with unique crystalline structures, could conceivably affect neutrino interactions or the propagation of light within detectors. Yet these explanations remain speculative, offering possibilities but not certainties. With every new anomaly, the boundary between what is understood and what remains mysterious grows thinner, reminding scientists that, even in one of the most controlled, monitored environments on Earth, nature can still defy expectation. Despite exhaustive analysis, no cosmic source, atmospheric interference or equipment fault accounts for the frequency, intensity or direction of these events. The neutrino bursts continue to resist categorization, and the more data scientists gather, the more the mystery deepens. Each detection seems to challenge assumptions about the behaviour of the universe at its most fundamental level. Researchers remain both fascinated and unsettled, aware that the Antarctic ice, a place long thought to be silent and inert, may be recording signals from realms they cannot yet access or comprehend. The persistent anomalies have transformed the detectors into instruments of both scientific promise and haunting uncertainty, capturing glimpses of phenomena that might never be fully explained. Within the luminous flashes of Cherenkov light, traces of the unknown persist, recorded with precision yet defying understanding. The Antarctic neutrino source events occupy a liminal space between human knowledge and the vast, inscrutable universe, where advanced instruments detect patterns that hint at deeper truths without revealing them fully. For those who study them, the ice offers both data and an unshakable sense of wonder at the limits of comprehension. Each unexpected signal pulses like a subtle reminder that the universe still harbours forces beyond the reach of our understanding. The Greenland impact structure under ice. Scientists examining subtle anomalies in Greenland's ice sheet were struck by patterns that refused to match any known geological formations, hinting at a hidden history buried under kilometres of frozen crust. Early satellite imagery displayed faint echoes that did not conform to expected bedrock continuity, and glaciologists initially questioned whether the irregularities were artifacts of imaging techniques. As teams cross-verified data using multiple instruments, the patterns persisted, revealing a mysterious phenomenon beneath a landscape long assumed uniform and stable. This discovery immediately challenged conventional assumptions about the region and hinted at an event of extraordinary magnitude, long concealed by the ice itself. Advanced radar scans revealed echoes that suggested abrupt transitions in the bedrock, irregularities so precise they could not be explained solely by glacial flow or tectonic pressure. Subtle undulations and sharp ridges emerged in the digital reconstructions, hinting at violent forces shaping the Earth beneath the ice. By layering radar imagery with gravimetric and seismic surveys, researchers constructed a detailed three-dimensional model that confirmed the anomaly's scale and complexity. Each new scan amplified the mystery, suggesting a formation unlike any other known in the Arctic, and inviting speculation about events that would have had dramatic consequences for the planet. Further analysis confirmed that the signals corresponded to a massive structure, its diameter spanning tens of kilometers, with depth and shape indicating immense energy at the time of formation. Geophysicists quickly recognized that such an anomaly could only result from a catastrophic impact, yet the absence of surface devastation or scattered ejecta created a paradox. The ice had concealed a history of violence, preserving the imprint of forces strong enough to deform bedrock and potentially disrupt regional geology. Researchers were forced to reconsider how catastrophic events can remain invisible, buried beneath layers that seemed impervious to time and change. Seismic and radar analyses suggest that the Greenland structure spans roughly 31 kilometers in diameter, with a central depression and concentric fractures radiating outward beneath the ice. Modelling of the impact energy indicates a collision comparable to some of the largest known craters on Earth. Yet, unlike these, it leaves no evidence of surface ejecta due to complete burial by glacial ice. Sediment cores collected above the site reveal disturbed layers, hinting at violent subterranean upheaval at the time of impact. This hidden monument challenges conventional timelines, raising questions about the environmental effects such an event may have had on global climate in prehistory. Models of impact energy suggest that any collision capable of creating this formation would have released forces far exceeding the largest volcanic eruptions in recorded history. Simulations indicate that the blast would have fractured bedrock over wide areas, sent shockwaves through the crust, and melted significant portions of the overlying ice. If such an event occurred during a glacial period, the consequences for ice movement and climate could have been profound, yet Greenland today shows remarkably few signs of such upheaval on its surface. This contradiction between expectation and observation deepens the sense of mystery surrounding the impact, leaving researchers to grapple with the silent record beneath the ice. Dating the structure has proven elusive, as ice movement and shifting sediment layers obscure traditional chronological markers. Radiometric techniques applied to rock fragments recovered during limited drilling attempts offer a wide range of possible ages, some suggesting the event predates known glacial cycles, others hinting at a more recent occurrence. The uncertainty fuels debate among geologists, who weigh the possibility of an ancient cataclysm against a less dramatic but equally puzzling alternative. Each new date challenges prior assumptions, reinforcing the notion that the formation is both extraordinary and largely inaccessible to straightforward analysis. Adding to the mystery is the lack of corroborating evidence in surrounding regions. An impact of this magnitude should have left ejecta deposits or shocked minerals detectable over vast distances, yet surveys yield little confirmation beyond the crater itself. This absence of surface traces raises difficult questions. Could Greenland's ice sheet, unique in thickness and movement, have masked the effects entirely? Or does the structure represent a type of impact previously unrecognized by geologists, one that behaves differently from all known collisions in the geological record? Each possibility deepens the sense of an unresolved enigma. The ice above the structure both preserves and obscures its features, creating a natural archive that resists direct observation. Penetrating layers require highly sensitive radar and seismic instrumentation, while drilling carries the dual risk of contamination and equipment loss in extreme conditions. Researchers must interpret indirect signals, often reconciling slight variations in density or reflection patterns with models of impact dynamics. Every measurement provides insight, yet simultaneously raises more questions. How did the ice respond to the event? How has it shifted over millennia? The challenge underscores the delicate balance between observation and uncertainty. Geologists have proposed several hypotheses to explain the anomaly, ranging from asteroid strikes to cometary impacts, each attempting to account for its scale, depth, and apparent lack of surface evidence. One theory suggests an unusually low-angle collision, which could dissipate energy differently, concentrating destruction below the ice while leaving minimal surface disruption. Another posits a fragmenting object, dispersing force over a wider area than traditional impacts. Yet none of these explanations fully reconcile all data, leaving the formation in a grey area between known geological processes and phenomena yet to be understood. Modern expeditions have drilled into portions of the site, uncovering fragmented rock, deformed strata, and minerals exhibiting signs of shock metamorphism. Each sample offers tangible proof of immense energy, yet interpreting their arrangement and formation remains complex. Scientists compare these fragments to known impact sites worldwide, seeking patterns that might clarify origin or timing. Instead, the Greenland formation defies easy comparison, existing in a class of its own. Its uniqueness emphasizes both the planet's capacity for concealment and the limitations of human investigation in extreme environments. The surrounding landscape, seemingly calm and stable, contrasts sharply with the hidden violence beneath. Smooth ice ridges and glacial plains belie the energy that must have sculpted the bedrock below, creating a striking dissonance between appearance and reality. This juxtaposition underscores the planet's ability to preserve traces of monumental events while allowing their consequences to fade from view. Each new survey or sample serves as a reminder that Earth's history contains surprises and forces that lie far beyond ordinary perception, waiting to be uncovered by those patient and curious enough to probe them. Each dataset reinforces both the scale of the anomaly and the limits of current scientific knowledge. The Greenland impact structure challenges assumptions about Earth's capacity for concealment, the preservation of ancient events, and the mysteries that remain locked beneath layers of ice. For researchers, it is a stark reminder that even in a world increasingly mapped and studied, enormous forces have shaped the planet in ways we're only beginning to understand. The structure persists as both record and question, a silent testament to a cataclysm that resists full comprehension. The Greenland impact structure endures in silence, a relic of a cataclysm the world has yet to fully uncover. The Siberian radioactive ice traces. A biting wind swept across the endless Siberian tundra, where snow drifts crested like frozen waves and the horizon dissolved into a pale haze. Within the temporary research station, researchers carefully unpacked ice cores that had lain undisturbed for centuries, each stratum a delicate, translucent archive of the past. Tiny bubbles, mineral flecks, and dust grains shimmered in the fluorescent light, a frozen record of seasonal change and atmospheric exchange. Only after meticulous isotopic analysis did the anomaly emerge. Discrete layers marked by elevated radioactivity appeared in locations and at depths that should have been untouched, entirely inconsistent with any documented human activity. The discovery stirred an unease that spread quietly through the team, suggesting the ice was concealing secrets beyond known history. The initial measurements were precise and unambiguous. Gamma spectroscopy revealed cesium-137 and plutonium-239 concentrations far above background levels, their presence confirmed repeatedly by multiple laboratories. Each core, meticulously cleaned and prepared, retained the same anomalous patterns. What began as a curiosity grew into a mystery. The radioactive layers were sharply defined, forming consistent strata rather than scattered deposits. Unlike fallout from mid-20th century nuclear tests, which typically disperses broadly and unpredictably, these layers were coherent, measurable, and remarkably persistent. The realization that the ice held such inexplicable evidence transformed the routine analysis into an investigation bordering on the unexplainable. Patterns unfolded that extended across cores taken hundreds of kilometers apart, implying that whatever caused the anomaly was regional, not local. Statistical analyses revealed recurring isotopic concentrations, hinting at a phenomenon with periodicity that defied conventional explanation. The deeper the team examined the cause, the more the layers seemed to whisper of an event or process beyond the reach of recorded history. Each repetition across distant cores reinforced the idea that this was not contamination or a laboratory error, but a tangible record of something unknown, captured and preserved by the patient accumulation of ice. Historical records provided little insight. Archival data from nuclear tests, industrial accidents, and atmospheric releases were cross-checked with precision. The timing, depth, and chemical composition of the radioactive layers failed to match any known incident. Fallout from the Kishtim disaster in 1957, while regionally significant, did not correspond to the precise isotopic ratios observed, and global nuclear testing schedules were similarly inadequate to account for the concentration or placement of the markers. The ice held evidence of a process or an event that left almost no trace outside its frozen archive. In effect, Siberia itself had become a repository for an enigmatic, unrecorded history. Scientific debate grew intense, with researchers proposing a variety of explanations, each partial and incomplete. Some suggested unusual atmospheric circulation patterns capable of concentrating radioactive aerosols, while others considered rare natural fission events or cosmic interactions capable of producing detectable isotopes in ice. Each theory addressed aspects of the anomaly, but failed to reconcile all observations, leaving the trace layers as persistent evidence of an unknown mechanism. The tension between plausible hypotheses and stubborn anomalies deepened the mystery, highlighting both the limits of current understanding and the extraordinary nature of the discovery. The isotopic ratios were perhaps the most confounding element. Detailed analysis of decay signatures indicated sources inconsistent with conventional anthropogenic fallout, with patterns that implied deposition under conditions no known historical event could produce. Minor isotopes, including traces of uranium and strontium, suggested interactions that did not conform to expected geochemical pathways. Each layer acted as a puzzle piece, offering tantalizing hints yet resisting full interpretation. The ice, though silent and inert, seemed to narrate a story in chemical code, one that human observation could only partially decipher. To establish the precise age of the radioactive layers, scientists employed advanced ice core dating methods, including annual layer counting, isotopic diffusion analysis, and volcanic ash markers embedded within the ice. These techniques revealed that some of the anomalous layers corresponded to periods long before the mid-20th century, suggesting that the radioactive events could predate known nuclear activity. The correlation between isotope concentrations and independently dated layers offered a timeline that both intrigued and baffled researchers, as it implied a phenomenon occurring repeatedly over centuries, yet leaving no record in human history or environmental documentation. Periodic layering emerged as a particularly puzzling feature. The sequences repeated with near mathematical regularity, as if the ice had recorded an unknown rhythm across centuries. Researchers mapped these repetitions meticulously, noting both vertical spacing and isotopic concentration. This suggested either a recurring natural process unknown to climatology or a series of discrete events acting with unusual precision. The rhythm imparted an eerie sense of intentionality, as though the frozen record had been shaped by forces or phenomena invisible to contemporary science. Each measurement added clarity in one sense and deepened ambiguity in another. Concentration gradients, isotopic ratios, and decay rates offered precise data, yet the origin, scale, and timing of the underlying events remained elusive. Every analytic method, from high-resolution mass spectrometry to alpha particle counting, reinforced the reality of the anomaly while emphasizing its resistance to explanation. In this interplay between certainty and enigma, the ice became both archive and riddle, tangible yet unknowable, a reminder that nature can preserve events far beyond human perception. Comparisons with other polar regions underscored the peculiarity of Siberia's record. While cores from the Antarctic and other Arctic sites reflected expected levels of background radiation and anthropogenic fallout, the Siberian ice diverged sharply. Its layers were defined, discrete, and repeating in a manner not seen elsewhere, hinting at local or regional factors that had preserved this evidence uniquely. The anomaly was therefore both spatial and temporal, a phenomenon confined to Siberia yet defying explanation. its persistence challenging conventional understanding of environmental processes and historical events. Modern analytical technology revealed further depth. Techniques like neutron activation analysis and multi-collector mass spectrometry uncovered subtle isotopic variations and trace elements invisible to older instruments. Even with these advanced tools, the layers resisted conventional interpretation, leaving scientists confronting a record that was at once precise and inexplicable. The combination of repeated measurements, geographic distribution, and chemical detail rendered the anomaly undeniable yet unresolved, a compelling reminder that some forces in the natural world leave footprints that outlast human comprehension. Decades of research, re-examination, and interdisciplinary analysis have still not produced a satisfactory explanation. The ice continues to preserve its silent testimony, holding a record of events that left little to no trace beyond these frozen layers. Scientists are left with the tension of knowing the anomaly is real, yet the source, cause, and implications remain obscure. Each layer is a fragment of a narrative the world has yet to decode, a whisper from a time and process that challenges the very limits of understanding. The Siberian ice, patient and immutable, maintains a memory that refuses to be fully explained. These radioactive traces endure in quiet mystery, a hidden record of forces the world has yet to comprehend. The Polar Night Psychological Collapse Records. The first weeks of the polar night draped the Arctic landscape in a darkness so complete that even familiar landmarks vanished into an endless void, and within this shadow, expedition logs hint at the beginning of an unnerving transformation in those who endured it. Light, when it appeared at all, was muted and fleeting, leaving the station bathed in perpetual grey or pitch-black night. Inside the small wooden outposts, explorers relied on artificial illumination and routine schedules to maintain a sense of normalcy. Yet the journals, carefully maintained over decades, began to record subtle deviations from ordinary behaviour, the earliest signs that isolation and darkness might exert a profound psychological influence on human occupants. Murmurs in the daily journals described subtle disturbances at first, irritability over minor tasks, fleeting moments of disorientation, and a creeping sense of restlessness that seemed to grip each member in quiet succession. Officers and medical personnel often noted tension during routine duties, noting small conflicts between team members over trivial matters such as equipment placement or meal schedules. These minor irritations, though easily dismissed, were recorded meticulously, suggesting that the expedition leaders themselves recognized the early warning signs of mental strain. Such observations, repeated across independent expeditions, hint at a pattern that transcends individual temperament and points toward environmental influence. As the darkness deepened, the logs record memory lapses, poor judgment, and difficulty coordinating routine operations, creating a cascade of operational and interpersonal stress that compounded with every passing week. Researchers misfiled samples, forgot scheduled communications with other stations, and occasionally repeated the same tasks in ways that disrupted daily workflow. These disruptions were not isolated. Multiple members displayed similar symptoms simultaneously, a phenomenon that puzzled psychologists studying the logs decades later. The cumulative effect of these errors suggests a slow erosion of cognitive resilience, one that intensified as the polar night pressed relentlessly onward. Several accounts describe strange sensory experiences that appeared to occur in unison among multiple team members, with shadows moving where none should exist and whispers echoing in the stillness of otherwise silent outposts. Some explorers reported seeing fleeting figures in the snow or at the edges of their vision while performing routine outside duties. Others documented hearing knocks, footsteps, or faint conversations when no one was present. The consistency of these hallucinations across different expeditions and time periods has baffled researchers, raising questions about whether extreme environmental conditions might synchronize cognitive disturbances in ways still poorly understood. Medical entries, written in precise terms yet tinged with concern, document tremors, bouts of nausea, and disrupted sleep cycles, suggesting that the environment was exacting a measurable toll on both body and mind. Even those with prior experience in extreme climates were not immune. The logs describe involuntary shivering, sudden dizziness, and psychosomatic complaints that appeared without clear physiological cause. Physicians and station medics often attributed these symptoms to the combined effects of caloric deficit, cold stress, and circadian disruption, but patterns remained inconsistent, leaving many phenomena unexplained. One particular record details a researcher pacing endlessly along the station corridors, repeating tasks in a loop, while another experienced vivid visions of figures in the snow, demonstrating a level of cognitive breakdown that defied prior understanding. These incidents were sometimes brief, but occasionally persisted for hours, and they often left other team members bewildered and concerned for safety. Journals describe interventions ranging from enforced rest to reassignment of duties, yet the underlying cause remained elusive, suggesting an external factor, or perhaps an environmental stressor inherent to the polar night itself. To establish a chronological framework for these episodes, analysts of expedition logs cross-referenced dates with solar and lunar cycles, local meteorological records, and station schedules. They discovered that the most severe psychological disturbances coincided not only with prolonged darkness, but also with periods of heightened atmospheric pressure and temperature inversion, conditions common in the polar night. This correlation hints that the combined effects of sensory deprivation, environmental extremes, and circadian disruption may interact in ways that amplify cognitive vulnerability, though the precise mechanisms remain undetermined. Investigators noticed that these episodes corresponded closely with the duration of darkness and the extreme cold, implying that the combination of sensory deprivation, circadian disruption, and isolation could amplify psychological fragility beyond expected thresholds. Sleep schedules were disrupted by the absence of natural cues, and artificial lighting, while helpful, could not fully replicate the restorative effects of daylight. Team members documented feelings of temporal disorientation, difficulty distinguishing days from nights, and a creeping sense of time stretching indefinitely. The environment itself seemed to warp perception, subtly undermining cognition while remaining imperceptible to the casual observer. Experts have hypothesized that these effects arise from a confluence of environmental stresses, neurochemical imbalances, and sensory deprivation, yet the precise mechanism remains unverified and does not fully account for the consistency of phenomena observed across decades. Some researchers have suggested parallels to seasonal affective disorder or extended isolation in submarine crews, yet the Arctic context introduces extreme cold, near-constant darkness, and logistical confinement that create a far more potent cocktail of stressors. Modern studies using polar analogues, including simulated stations in Antarctica, have replicated some symptoms, but the collective and sometimes synchronous hallucinations documented in historical logs remain unexplained. From early 20th century Arctic expeditions to contemporary polar research stations, logs reveal a striking pattern. Similar episodes emerge regardless of technological advancement, training, or individual resilience, suggesting a persistent and unexplained environmental influence. Even as stations grew more comfortable and life support systems improved, the psychological impact of prolonged darkness persisted, demonstrating that technology alone cannot mitigate the effect. This continuity implies that the phenomenon is embedded in human physiology and cognition when subjected to the extreme conditions of the polar night, challenging assumptions about the limits of adaptation and preparation. Even seasoned explorers, acclimated to harsh conditions, succumbed in subtle and sometimes dramatic ways, underscoring an unsettling truth that human cognition is far more fragile in polar darkness than conventional experience or expectation would suggest. Logs recount incidents of interpersonal conflict escalating to emotional breakdowns, lapses in judgment with near-fatal consequences, and individuals requiring extended recovery periods. The repeated documentation across independent expeditions implies that the polar night can impose a psychological toll as reliably as any physical hazard, yet remains largely invisible until carefully analysed. The combination of silence, endless night, and isolation creates a space in which the mind can unravel, leaving traces of shared hallucination, paranoia, and altered perception meticulously recorded in logs that modern science has yet to fully interpret. Each journal entry, observation, and medical note provides a fragmentary window into an invisible threat, a force not of ice or wind, but of darkness itself, shaping consciousness in ways the human mind is ill-prepared to resist. These records suggest that beneath the surface of exploration, an enduring mystery persists, one that challenges both the limits of endurance and the certainty of rational perception. This darkness, unbroken and unyielding, seems to hold the human mind in a grip that no preparation, training, or technology has yet learned to escape. The Antarctic ice quake swarms. The ground beneath the Antarctic plateau shivered without warning, sending a cascade of trembling vibrations that baffled scientists who had expected only stillness in the frozen expanse. Instruments recorded the quakes in near real time, yet the origin of these sudden bursts of energy remained elusive. Vast stretches of ice seemed to fracture invisibly, transmitting tremors that could be felt for miles, while leaving the surface deceptively smooth. Field teams described an eerie sensation, as if the continent itself was alive, shifting in ways that defied the predictable slow creep of glacial movement. Each recorded pulse raised more questions than answers, hinting at a phenomenon beyond current understanding. Seismic sensors began reporting clusters of pulses in regions long considered geologically inert, revealing an activity pattern that contradicted conventional models of ice movement. These tremors were neither isolated nor sporadic. They emerged in swarms, sometimes dozens within hours, producing faint rhythmic vibrations that no one had anticipated. The lack of a nearby fault or known stress point challenged researchers to rethink fundamental assumptions about glacial and tectonic processes. Instruments showed that the ice itself could store and release energy in sudden bursts, yet the mechanism and triggers for these pulses remained mysterious. Distinct sequences of tremors unfolded across the ice sheet, sometimes appearing in rapid succession, other times separated by long intervals, yet all forming a rhythm that defied known natural processes. Analysis revealed that these swarms could cover vast distances, spreading energy across hundreds of square kilometers without a clear direction or a predictable pattern. Some swarms appeared to fade only to resurge with greater intensity hours later. The irregularity of these events made them difficult to model, and yet the data consistently indicated a recurring invisible force shaping the movements beneath the frozen surface. Massive ice ridges and hidden crevasses dominated the landscape, but careful analysis showed these features could not explain the sudden bursts of energy radiating through the frozen terrain. Remote sensing and high-resolution satellite imagery confirmed that many tremors occurred in areas with no significant surface disruption. Even detailed surveys of subglacial lakes, ice streams, and basal topography failed to locate a sufficient source of energy. The ice itself appeared to act as both conduit and reservoir, accumulating stress in ways scientists had not previously documented, making the continent seem unpredictable and alive. Scientists deployed arrays of advanced instrumentation, from borehole seismometers to satellite radar, each capturing fragments of motion that hinted at unseen forces operating beneath the surface. Networks of sensors allowed researchers to triangulate epicenters with unprecedented accuracy, revealing clusters that sometimes formed linear paths, circular concentrations, or diffuse patterns. Yet no model could consistently predict the timing or magnitude of subsequent tremors. Observers noted subtle variations in amplitude and frequency, as if each swarm carried its own signature, distinct from anything recorded in other glacial regions. Certain swarms emerged in areas with no prior seismic history, generating intense tremors while leaving no detectable deformation, confounding glaciologists and geophysicists alike. In some locations, ice vibrations registered across multiple instruments without any visible cracks or fissures, suggesting that the release of energy was occurring within the ice sheet itself, not through conventional tectonic processes. This invisible activity raised unsettling questions about the internal dynamics of Antarctica's ice, and whether unseen structures or pressures were driving these tremors. Across polar regions worldwide, ice movements rarely produce similar patterns, marking Antarctica as uniquely active and unpredictable in its subterranean quaking behavior. Researchers compared data from Greenland, Alaska, and Patagonia, finding sporadic quakes and basal slips, but nothing approaching the intensity, repetition, or scale of the Antarctic swarms. The continent's immense ice sheet, combined with its extreme cold and unique subglacial features, seems capable of producing seismic phenomena, unlike anything observed elsewhere. This distinctiveness has drawn the attention of glaciologists, seismologists, and climatologists alike, each searching for clues within a seemingly impenetrable environment. Proposed explanations include sudden basal water shifts, fractures under immense pressure, or hidden geothermal activity, but none can fully account for the scope and irregularity of these swarms. Some scientists suggest that melting or refreezing at the ice base creates pockets of energy that release unpredictably, while others point to ice shelves flexing under extreme stress. Subglacial volcanic activity has been considered, though evidence remains limited and inconsistent. Each hypothesis addresses part of the puzzle but fails to reconcile the broader pattern of repeated, high-frequency tremors spanning thousands of square kilometers. Researchers stationed nearby reported feeling vibrations through their equipment and even through the soles of their boots, noting the uncanny sensation of the continent itself reacting as if alive. Acoustic monitors captured deep, low-frequency rumbling, sometimes accompanied by faint cracking sounds, amplifying the sense of unease. For those in the field, the tremors were more than data points. They were tangible, unsettling reminders of the raw forces at work beneath a frozen landscape that appears calm and motionless at first glance. Personal accounts underscore the visceral nature of these swarms and their potential to surprise even the most experienced polar scientists. Understanding these swarms is critical for anticipating ice sheet stability, modelling glacial behaviour, and predicting the potential impact on sea levels. Yet the unpredictable patterns challenge even the most sophisticated simulations. If the ice can release energy in these sudden, clustered pulses, it may affect the movement and fracture of surrounding ice, potentially accelerating calving events or destabilizing previously stable sections of the sheet. As climate change alters temperature and stress conditions, the unpredictability of these swarms becomes even more significant, raising both scientific and logistical concerns for those working on or studying Antarctica. Despite years of observation, no model fully explains the swarms, leaving Antarctica a place where frozen silence can erupt without notice, reshaping our understanding of the forces beneath the ice. The continent's interior, vast and remote, continues to behave in ways that elude prediction, challenging the assumption that ice moves only slowly and quietly. Each new swarm recorded adds another layer of complexity to a phenomenon that blends natural mechanics with a seemingly inexplicable rhythm, a reminder that even the most remote places on Earth can harbour secrets that defy comprehension. The icequake swarms continue to pulse unpredictably, a hidden rhythm beneath the Antarctic plateau that refuses to yield its secrets to science. The Arctic ancient tool discoveries. Fragments of chipstone emerged from the permafrost as if deliberately placed, their presence immediately challenging assumptions about human survival in the far north. The objects lay half buried in icy soil, glinting faintly in the low Arctic light, their edges sharp enough to have cut through animal hides or plant fibres. Archaeologists huddled against the bitter wind marvelled at the incongruity. Such finely made tools, surviving for thousands of years in a landscape where humans were believed to have had no foothold. Even the surrounding terrain, a mix of hardened ice, scattered boulders, and treacherous crevasses, seemed to resist habitation, yet these artefacts persisted, silently defying expectations. Archaeologists carefully recorded the site, brushing away centuries of frost and compacted sediment, while noting the precise orientation of each stone. Thermal tools, delicate brushes, and ice chisels were employed to extract the fragile artifacts without damage, and each fragment was photographed, measured, and mapped in meticulous detail. Patterns began to emerge. Clusters of tools near small depressions that may have served as temporary shelters, sequences suggesting repeated activity, and areas where food processing could have occurred. The precision of excavation, combined with the apparent intentionality of placement, created a narrative that extended far beyond mere chance. Close examination revealed sharp edges and consistent shaping, indicating tools fashioned for cutting, scraping, and hunting rather than accidental rock fracture. Where patterns under magnification showed striations consistent with skinning and butchering, while some edges exhibited polish from repeated contact with animal hides or wood. A few fragments even displayed faint traces of ochre, suggesting either symbolic marking or functional treatment to strengthen the stone. The craftsmanship was unmistakable, reflecting planning, skill, and a surprising degree of sophistication for a population operating in such an extreme environment. Radiocarbon tests and stratigraphic studies placed these tools thousands of years earlier than previously accepted northern human settlements, directly challenging established migration timelines. Layers of ice and soil above and below the artifacts created a timeline that conflicted with conventional understandings of when humans could endure polar conditions, revealing occupation far earlier than expected. Comparisons with other northern sites highlighted a discrepancy. These tools predated known northern settlements, implying that humans had ventured into regions once considered uninhabitable, surviving long enough to leave a tangible trace. At the time of their use, the region would have been brutally cold, with months of continuous darkness, scarce vegetation, and limited animal life. Survival would have required careful planning, knowledge of shelter construction, food preservation, and the ability to track and hunt migratory species in extreme weather. Seasonal variations, from near-constant daylight in summer to complete night in winter, imposed psychological and physiological challenges. Yet the placement and repetition of these tools suggest that humans managed these conditions with strategies sophisticated enough to leave enduring artifacts for modern researchers to uncover. Similar artifacts elsewhere in Siberia and northern Europe offer parallels, yet the Arctic finds remain uniquely distant and difficult to reconcile with prior models of human mobility. Patterns of tool-making, material selection, and spatial distribution show similarities to temperate sites, yet the Arctic location demands higher levels of endurance, planning, and adaptability. These tools are not merely functional, they represent a form of ingenuity shaped by an unforgiving environment, suggesting migration patterns and survival strategies that challenge assumptions about early human dispersal. Evidence from soil analysis and ice melt patterns suggests that early Arctic inhabitants may have exploited seasonal thawing to access hidden plant resources and freshwater streams otherwise locked beneath permafrost. Traces of moss, lichen, and small aquatic organisms near tool clusters indicate that these humans timed their activities with subtle environmental rhythms, perhaps moving between foraging and hunting zones as conditions allowed. Such a nuanced understanding of microenvironments reveals an adaptability and ecological awareness that would have been essential for survival, offering a glimpse of intelligence finely tuned to the extreme polar landscape. Some artifacts hint at cultural or symbolic practices, adding layers of mystery to their purpose. Certain stones appear deliberately shaped in non-utilitarian forms, while pigment traces on others suggest early attempts at marking or decorating tools. Small groupings near potential hearth sites imply communal activity or ritualistic behaviour, hinting at social structures that modern archaeologists can only speculate about. These possibilities broaden the narrative. Humans were not only surviving but organising, communicating, and perhaps expressing symbolic thought in landscapes where survival itself was an achievement. The sophistication and placement of these tools hint at organised survival strategies, revealing cognitive and cultural adaptability far beyond expectations for humans of that era. Repeated use in strategic locations implies knowledge of seasonal patterns, hunting grounds, and the careful conservation of resources. Each cluster tells a story of foresight, skill, and cooperation, suggesting that humans could anticipate environmental challenges and respond with effective solutions in extreme isolation. Some scholars have questioned the artifact's origins, proposing natural formation or later intrusion as explanations, yet the consistency of flaking patterns, the wear on edges, and their placement in undisturbed sedimentary layers counter most objections. Peer-reviewed studies emphasize the compelling nature of the evidence. Repeated findings across multiple sites strengthen the argument for human agency, while scientific documentation ensures that interpretation is grounded in fact rather than speculation. Recent Arctic expeditions have revealed additional tool clusters, reinforcing the pattern of human activity while highlighting the challenges of working in extreme remote regions. Scientists endured sub-zero temperatures, blizzards, and shifting ice to map these sites, uncovering evidence of temporary shelters, hearth remains, and food processing areas. The logistical difficulties of preserving and transporting artifacts from such inaccessible locations make each find particularly remarkable, underscoring the commitment required to document human history in extreme climates. Each discovery forces a re-evaluation of early human migration routes, demonstrating that our ancestors were capable of surviving in conditions long thought impossible. These tools suggest that humans were exploring, adapting, and thriving in Arctic landscapes far earlier than previously acknowledged. Their existence compels historians and archaeologists to reconsider assumptions about technological development, social organisation, and environmental mastery. The Arctic, once imagined as a barrier, instead becomes a proving ground for human ingenuity and endurance. The true purpose and extent of these northern ventures remain shrouded in uncertainty, leaving the Arctic as both a stage and a silent witness to human determination. Sparse evidence, combined with the precision and consistency of the artifacts, paints a portrait of a people whose knowledge and skills were extraordinary, yet remained frustratingly opaque. While speculation can suggest hunting, migration, or exploration, the lack of written records leaves only these tools to tell the story. They are fragments of human endeavour in a landscape that continues to defy explanation. These ancient tools endure as silent witnesses, hinting at a human story in the frozen north that refuses to be fully understood.